Hey there, my name is Max and welcome to my Python for Software Engineering Bootcamp. I'm super excited to have you. Now, because you joined during the early bird phase, you're actually going to get special access to 3 of my other courses, which is going to help you out a lot. So the first course is going to be the Job Ready SQL, then the second course is going to be the Concurrent and Parallel Programming in Python, and you're also going to get access to my Terminal for Beginners course. You can find all of those on my course page, and you're going to have coupons in the description below, which will give you free access to those. So make sure to grab those. For the SQL course, I would recommend starting that one right before we jump into databases. For the concurrent and parallel programming, I would recommend doing that one after you finish this course. And the terminal one, I would recommend starting that one before we do the Docker phase. Now, over the next coming weeks, we're going to continue dripping out the final contents of Docker, databases, cache, as well as using GitHub to continuously build and deploy your code. So look out for those extra additions. And until then, I hope you enjoy all the content that's already there. I hope you learn a lot. And by the time you reach the end of this course, the rest should probably already be dripped out for you. So just continue on learning, and I'm super excited for your journey and to help you be a part of that. Hey there and welcome. So in this lesson, we're going to learn how we can actually download the software that we need to start writing Python code. So I'm going to recommend to you to actually get PyCharm, which is my favorite IDE that I've worked with, but other popular ones are Visual Studio Code. And then there's also one that you can find if you go to python.org. You'll also be able to download a Python IDE from here. Personally, I really prefer the one from JetBrains. It has a lot of really cool features that are really nice to just use later on. It's also the one that I'm going to be using throughout this whole course. So yeah, I would generally recommend this one. But again, the python.org one is a very standard one, a very basic one. Visual Studio Code is also a very popular one. But PyCharm is a great option. So to get that, we're going to go to jetbrains.com. And from here, we're going to click on Developer Tools. We're going to click on PyCharm. Now, there are 2 versions of PyCharm available. So we can click on Download here. One of them is the professional version, and then the other one is the Community Edition. So the professional version is a paid license, and the community one is the free one. So obviously, we're going to go with the Community Edition. But the professional version does have a lot of really nice things, and if you want to, you can see there's a free trial. You can try that out. Your company may or may also not have a JetBrains license, so it's possible that you'll be able to get the professional PyCharm version using that license. So if you have that option, I would highly recommend it. But if not, the Community Edition is going to do great too. So we're just going to hit download here. Now, of course, if I'm currently on a Mac, but if you're on Windows or Linux, it'll probably pop up to whichever the right one is. But yeah, you're just going to click on the right one, just hit download, and that's going to start the actual downloading of the installable that you need. And once you have that, you're just going to walk through the setup with it. I already, of course, have it installed. So I'm going to show you what we're going to do once you finish that setup, once you've just gone through those basic installation steps, open up the executable, open up the .dmg file that we have here, just click next, 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 and installed it. So we're going to go, or I'm going to go to my I'm going to pull up my Finder here, and I'm going to go to the documents. Now, you don't have to do this in the documents. You can do this literally anywhere. You can also do it on the desktop if you want. I put a lot of stuff actually on my desktop. So when I have projects, I usually have one big folder for whatever, that main overarching theme is that I'm working on. And then I'll have smaller subfolders in there and just kind of layers and layers and layers of folders. But yeah, I'm going to do this one in the document, but again, you don't have to do it in the documents. This is just where I'm going to create it. You can totally create it on the desktop if you want, or you can even do it in the downloads. I would recommend keeping that clear because I usually clear my downloads quite regularly. So I'm just going to create a new folder here. That's going to be our first Python project. And we're just going to have it here, just empty for now. So then I'm going to open up PyCharm, and you can see a project that I've been working on recently, building a small Reddit clone, but we're not going to get into that right now. So we're going to go ahead and we're going to go File, we're going to click on Open, and then we're going to navigate to that folder, wherever we created it. In my case, it's going to be the documents. And I'm going to click on the folder, which is currently empty. I'm just going to click Open. I'm just going to say this window. And then we're going to open then it's going to open the folder for us, and basically now we can start working in here. In case you don't have this view on the side here, you can actually go into View in the top, and then you can go into Tool Windows. And then here, if you click on Project, you can see we can open or close it. Well, we can close it by clicking the minimize. If we go into View and Tool Windows and Project, that will pop right back up. In this case, it actually kind of created a default file for us that we can start using, but I'm actually going to clear all of this because we're going to, start writing everything ourselves. But now we have a nice place where we can actually start coding in. And what's really nice about this is that we have this project structure, which as time goes on, we're actually going to be adding more files. We can add folders, and we'll be able to have the overview with everything. And actually, as you already saw, kind of in the sneak peek of my previous code that I've been working on, we're also able to have a lot of different windows open. And we also have some cool access, for example, to the terminal readily down here. So we're going to be making use of all of these things, obviously going through everything step by step. And this is actually just going to be our kind of like all-in-one development software. We can write all of our code, we can run it, we can, evaluate it and test it, and basically, just do all of the cool stuff. So yeah, that's kind of it for downloading this. Just make sure that you get to this step where you have PyCharm open and you have your folder open, and if it didn't create an empty file for you, no worries. So we can just delete this, and I'm just going to right click on my folder here. I'm going to click New. I'm just going to have a file. You can do a Python file, but I'm just going to click New File, and then I can call this main.py. The py will indicate that this is a Python file. So when we're writing Python code, basically we have all these options for like highlighting and code completion. So if you're writing Python scripts, I recommend that you add this .py extension, because it will make everything much easier to do with your development environment. Basically everything will kind of be detected for you. We don't need to call it main. You could really call it whatever you wanted. We could call it like project 1, or you could call it our first program, or whatever. I'm just going to keep it simple, and we'll just call it main.py. And yeah, just make sure you get to the stage where you have your folder open in PyCharm and you've now created a file, and then this is where we're actually going to start writing our code in. All right, so before we can jump into the coding, we still have to install Python so that we can make sure we're using a relatively updated version of Python, because by default, usually the version of Python installed on your machine is going to be a pretty old one. So we just want to make sure that we're using a relatively new one. So we're going to go to python.org here, and we're going to hover over this download section. It should already automatically identify what operating system you're on, and then you can just click on this button here. So in this case, we're going to be downloading Python 3.9.7. If this version is higher, it's not really going to make that big of a difference. And if you already have Python installed and it happens to be an older version, don't worry about it. I actually also usually use older versions of Python too. I'm not too worried about, having these larger upgrades. I usually work, I think, with Python 3.7. It will all work fine. But yeah, I generally recommend at least having Python 3.7, but if you're installing new, I recommend going to python.org here and just clicking on this download here, which is just going to download this file, this installer for us that will walk us through the installation process. For Windows, obviously the file that you're going to download is going to be a little bit different, but it will walk you through the same installation process. So we're going to open this up, and we're going to continue through here. And we're going to continue through here after making sure we read the README and the license. And I'm going to select my just standard hard drive to install this on. I'm going to click install here. It's going to ask me for my password in a second. All right, and then it's just going to go ahead and go through the installation process for us. This should go relatively quickly. All right, so there we go. So now we should have a good up-to-date version of Python installed. So I'm going to go ahead and close this here. I'm just going to move the installer to trash because we don't need it anymore. Now I'm going to head back to our PyCharm, and I'm going to go into the terminal here, and I'm just going to make sure that this version of Python was installed. So I'm going to go here into type in Python. Now I'm going to use this dash dash afterwards and type in version. Now you'll see in this case, it's going to be a pretty old version of Python. It's going to be version 2.7. So how can we reference a newer version? Well, we can do that using Python 3 here. But this for me is actually also an older version, as you can see. This is Python 3.6. So since we've installed Python 3.9, if I want to use that version of Python, I can type in here Python 3.9, and this is the version of Python that we've now just installed. And we'll come back to this later on, and we'll actually use this to run some of our code, but now we should have the latest version of, or the latest stable version of Python installed so that we can continue to use it. And again, if your version of Python is later, don't really worry about it too much. There isn't really going to be any changes that will happen that will change the way that the code is running. So just make sure that you have this recently up-to-date version of Python installed, and then you can just continue on. All right, so now that we have a place to code in and we have a version of Python that we can use that's relatively up to date, let's go ahead and write and run our first piece of code. Now we're going to go back and do PyCharm here, and we're just going to go into our main.py file. And in case this is not open, just double click it and it will open up. And we're just going to do, well, the basics of basically any initial programming language when you're learning it, which is going to be printing out hello world in our console here. So what we're going to do is we're going to type in the keyword print, and you'll notice that it gets color coded because my editor here recognizes that this is a Python keyword, and we'll talk about, or you'll see actually in a second what this does. And now I want to type in what it needs to print out. Unfortunately, I can't just type in hello world like this, because these are actually, or in this case, we'll be referencing variables, and we'll learn about variables later on, but really these words themselves aren't defined. And again, you'll see what this means later on, but if we want to have either in a word or in programming we actually call it a string, we need to put quotation marks around it. Now in Python, it doesn't matter if we use single quotation marks. So you can see if I highlight it, it will put quotation marks around it. But of course I could have also just, if I undo this here, I could put the quotation marks beforehand and I can put them afterhand. It doesn't matter if we have single quotation marks or double quotation marks, and we'll learn about strings in a second a little bit more in detail too. The most important thing is just that we have quotation marks around them. In some other programming languages, the single and the double quotation marks have different meanings. In Python, it doesn't matter. The most important thing is that you're consistent. If you use single quotation marks for strings, make sure you always use single quotation marks. If you use double, just make sure you always use double. Just be consistent. So now we have this string here is what it's called, but really it's just, well, it's 2 words, it's a sentence, it's just a sequence of characters. And this is the value, it contains the value of hello world. And so now we have the most basic Python program, which we'll see in a second is just going to print out this value in here in our console when we run it. So how can we run it? We're going to go to our terminal, and I'm going to type in here Python 3.9. I'm just going to make sure we're going to use the Python 3.9 version that we just installed. And then I'm going to reference this, and if you use tab, it should actually autocomplete main.py. If it doesn't autocomplete, just continue typing a little bit longer until you have enough of the file name there, because it will autocomplete if it's basically the only one that matches that pattern. So in this case, if we type Python 3.9 into our terminal here, and then we type, and then we put in here the name of the file that we want to run afterwards, and we hit enter, then it's going to run it for us. And you can see what happened is we have this hello world printed out. So we've just run our first program. Congratulations. You can see, well, Python, as you can see already, is a very, very user-friendly language, because all that we needed to do to write our first program was just write one single line of code. In most other programming languages, you need a bunch of other stuff around it to kind of have the base skeletal structure there so that you can then run it. But in Python, all we need is that one single line. And although, of course, it's not doing much right now, we can see we've already been able to run and do something. All that we've done right now, though, is just print this out in our console. But we were able to print out the sentence and this very short sentence, and you'll notice also the quotation marks are no longer there. And that's again because this value in here is a string and the contents inside are the value contained inside that string. But again, don't worry about that because we will have a separate lessons on strings in just a second. But again, congratulations on running your first program. So let's go ahead and learn some more new things with Python. All right, so we've just seen how we can print out something to our console. Now in this lesson, we're going to learn about variables. Variables are one of the core pillars of programming, and it's a really nice way for us to be able to save pieces of data, or just generally just be able to save values and reuse them later. Either we can manipulate them, we can update them, we can change them, we can take parts of them. There is so much that we can do, but it's really important in programming for us if we have something, if we have a piece of information, a piece of data, whatever that may be, that could be a text like this, hello world, it could be a number, anything, we want to be able to make sure that we can reuse this later again. So the way that we can do that is by saving it in something called a variable. So a variable in Python generally has, generally you want to just give it a descriptive name, not too descriptive of course, but you want to give it a good descriptive name so that you understand what's contained inside. So in this case, I'm just going to call it hello world underscore. And now we want to assign a value to this variable. And we're going to do that by having an equal sign here. And now on the right hand side, we can put the value that we want this variable to refer to. So in this case, I'm going to cut this value. I'm going to paste it here. So I want this hello underscore world variable, and again, I'll go back over again this in a second, to contain the value of this text here, of this string hello world. So now we can use this variable, and instead of putting this string here, we can just put this in here. And so now what happens is when we have a variable that's defined, and we've defined it up here because we've assigned a value to it. So now we can use it, and we can even reuse it multiple times as often as we would like. And whenever we call this variable, we will then look up the information contained inside. In this case, the information contained inside the hello world variable is this piece of text hello world, or rather the string hello world. So let's try running this. We're going to go type in Python 3.9, and I'm going to again run my main file here. And we can see the results that we're getting are the exact same like we had before. But we can also change it. So we can print out hello world, and then we can say here hello world. And I'm just going to take the same thing, but in this case, I'm just going to spell it lowercase. And then I want to print out the variable. And so now what we've done here is we've overwritten the value contained inside this variable. So if I run this now, we're going to see two outputs. The first one is from the first print statement here, which prints out the value contained inside this variable, hello world. The value contained inside this variable is the last value that was assigned to it, which is going to be this value here. So essentially, we have hello world. Then we look up what does hello world contain? What does this variable reference? It references this string. And now we take the same variable name and we assign a new value to it. So we've overwritten the variable. And now when we print out the same variable, we look up what are the contents of this variable, and we see these are the contents. Now the only difference here is that the H and the W is lowercase, so we can see here, even though we're printing out the same variable, because we've overwritten it at some point, it now contains different information, and well, now we're printing out slightly different results. So variables are extremely useful because, for one, we can reuse them, we can also update them, and it really allows us to have this core functionality of just being able to take information and go through a program flow and be able to use that information in places later on. And you'll see this is one of the core things that we'll just use all the time because it's really important for us to, when we have a bit of information, be able to hold on to it and be able to use it in a later place. Now we can also reference variables too. So we can also use like a previous variable. So let's say we want to have a second hello world. And this one we'll call hello world, or we'll just call this one hello world copy. So this is going to contain the same, or we want this just to contain the exact same value as contained inside here. So we can actually assign it the value contained inside this variable. So we don't even have to put a new value on this right-hand side. We can actually use variables on both sides. So on this side, we're going to assign the value since we have this equal sign here. And on the right-hand side is going to be the value that's going to be contained within. In this case, we're referencing a variable, we're referencing the variable that we've defined above called hello world. And so the value contained inside here is going to be the exact same value contained inside here. So if we run this, we see we're going to print out the exact same thing twice because the value contained inside each of these is the same. Now, again, just a quick note on the naming. In Python, it's generally standard to have everything be lowercase and to have separate words be separated by underscores. And what we can't do in Python is we can't separate variable names by spaces. A variable name has to be a connected series of characters. An underscore is included in this character. So generally in Python, variable names are going to be descriptive of what it contains. In this case, it's just hello world, but we'll see how this descriptiveness is useful later on, and this descriptiveness, or how this descriptiveness applies to different variables later on. And this descriptiveness is useful because when someone else, or when you are rereading your code and you haven't seen it for a while, it will much more clearly show you what is actually going on. And what is the information contained inside here? Because most of the time when we have variables, we're not just going to define it and use it a bit later down, but we're going to define it in one place and then maybe in a different section we're going to use it. And if we're not descriptive about what's contained inside here, we basically have to follow the whole path backwards until we see where it's first defined so that we understand what's contained inside. And then we need to go through the whole steps to understand if it was modified at some point and what's contained inside now. So it's important to be descriptive so that you know what you're dealing with. And again, the way that we do that in Python is by having everything lowercase and words are separated by underscores instead of spaces. Cool, so now that we know what a variable is, let's go back to those strings which we've also been using already and look at them in a little bit more detail. So the strings is the first data type that we're going to learn about, and strings are what we use to contain character or sentences or just general text information. They're very usable and very widely applicable, and you can basically contain a lot of information inside of them. The only thing is it's always going to be text, and the way that we define a string, like we also talked about previously, is either we have single quotation marks around or we have double quotation marks around. If we have a single and a double quotation mark, this doesn't work. To define a string, we have a starting indicator, which is either going to be a single or a double quotation mark, and then we also need to have the same ending indicator, which is going to be another quotation mark, either single or double, depending on what we use to start it. So if we have this, for example, and I just rerun the code again, we're going to see I actually print out this double quotation mark inside, because this is now contained within this string here. Our string is defined to begin with the first quotation mark here and the second single quotation mark here. And now this is just part of the text. And if instead I put double quotation marks around like this, well, now we again have a problem, because we start with a double quotation mark. Now this is going to be part of our text here, the single quotation mark. Oops, I didn't mean to flip those around. And now we've reached another double quotation mark, which means our string has ended. And now we start a new string with a single quotation mark, but we never finish it. So we can see here there's a red squiggly line. If we put our mouse over it, we can see that it's telling us we're missing a closing quote. So if I put another quotation mark here, I flipped those around. So if I put another quotation mark here, then it closes it properly. I think I flipped these around at some point, but now we're starting with a single, then we have a double, then we have a double, and then we have a single, and then we have two doubles here. Now if we try to run this, well, nothing much is going to change because there's really nothing extra contained inside here. The only difference is that we now basically have something contained within quotation marks. So what happens now if, maybe you want to use like an apostrophe, or you want to use quotes like we did in this case inside of your text? Because we talked about previously that you should also be consistent with either using single or double quotation marks. So let's say that I want to spell out here isn't, but I'm using single quotation marks. Well, this is going to be weird because we've basically indicated that our string is ending here. Then we have a t, which we know previously is now going to refer to a variable t, which is undefined. You can see here an unresolved reference to t, which means that the t variable, it's trying to look for the t variable because it's not contained within a string, is undefined. And then we just have another kind of lone single quotation mark here. So what we can do is something called an escape character, and that's going to be a backslash. And so what this backslash means is that the next character should not be treated as like a special character. So for example, the apostrophe should not be treated as a way to end the string, but rather it's just going to be a character that we want to use. So in this way, we can spell out isn't by using this special backslash here, which is just going to indicate that this next character that we have here should be treated differently than the way that it normally does. Now, if we have double quotation marks, we can do a very similar thing. If we want to say hello world, but if we want all of this to be in quotation marks, then all that we have to do here is just put a backslash and a backslash to indicate that these should just be treated as characters themselves. And then we can print it out and have quotes here like that. Now, there are a lot of other cool things that we can do with strings though. For example, we can join two strings together. So we can have one string that we're going to store in a variable called hello, which is going to be hello. We're going to have a second string that we're going to store in a variable called world, which is going to contain world. And now if we want to have hello world, we can join these two strings together by doing hello plus world. Now what this does is this basically takes the value here that we have here and the value here, and if the plus operation is defined for these two values and they're compatible with each other, then depending on what our values are, it's going to do this plus operation. Now for numbers, we probably kind of know what this plus means, but for strings, what it means is join them together. So we have the first value contained inside this hello variable, which if we look it up is this string here, hello. And then we have the second value that we have in this world variable, which contains the value world. And so what it's going to do is our value here is just going to take this, and to the back of this, it's going to put this. So if we run this, we can see that they've just been kind of stuck together. And we can't just do this once, we can actually do this many, many times. So let's say I want to have a space in between here. Well, one thing that I can do is I can add a space here, like this, or I can add a space here, like this. But either of these methods are not very nice because now we kind of have to know, did we put a space and where did we put it? And so a better way of doing this is just to have another plus here, and then we have a space, just the space character contained inside. So we're going to take our hello value, and then to the back of that, we're going to add a space, and to the back of these things together, we're going to add this world. And so if we run this, we can see now we're going to get back the exact same thing that we had before. But now we've used multiple variables and we've joined this information together using this plus operation. This string concatenation is what it's actually called. Now this is obviously extremely useful, but there are also some other cool things that we can do with strings. One of these things is called slicing. So let's say we have a string, but we only want to use a subsection of it. Let's say we have a very, very, very long piece of text, and we just want to look at, what's contained, like what are the first 5 characters? The first 5 characters contained inside this maybe super long piece of string, just so that we can get an understanding of like what's actually contained inside if we're reading it maybe from a file or something like that. So what we can do is something called slicing. And we're going to use print here, but I'll show you in a second how we can also use this in different ways. And if we put square brackets at the end, then we can actually refer to specific indices are what they called. So we can either refer to one individual index, and in programming we always start counting at 0. So in this case, our hello world variable, which we're referring to here, contains hello, so HELLO, it's going to be 5 characters. It contains a space, and then it contains world, which is going to be another 5. So in total, it has 11 characters within it. Now, if we want to look at, for example, the first character, then we're actually going to look at the index at position 0. Since programming, we start counting at 0. So if I run this, then we're going to have our hello world output here, which comes from this. And we're also going to look at the first character contained within this hello world variable, which is this H here. If we want to look at the second character, we can put in here a 1. If we want to look at the third character, we can put in here a 2, and so on. However, if we get out of range, for example, if we put in here 11, but actually we have 11 characters contained inside, but we start counting at 0, so the 11th index will actually refer to the 12th character. So this does not exist. And this is going to throw us an error that we can see here. The string index is out of range. So the string that we have here and the index that we're trying to refer to is bigger than the actual length of the string that we have. So what if we don't know how long our string is and we want to look at the last character? Well, one thing that we can do is we can use this -1, and that's going to look at the last character. So we can see here that's going to be the D from world. We can do -2, which is going to be the second last character, and so on. But right now, we've just kind of looked at individual characters, and that may not always be super useful. How can we look at subsections? How can we look at substrings? So let's say we have this hello world, and I want to look at what the first 6 characters are. So that's going to be HELLO space. So to look at the first 6 characters, we can say the index that we want to start at. We can say up to, but not including what index we want to go to, and then we can put our ending index. So let's say we want to look at the first 6 characters. We're going to go up to, but not including, so the second value here is always going to be up to, but not including the index 6. So that means we're going to look at index 0, 1, 2, 3, 4, and 5. So that's going to be the first 6 characters. And if we run this, we can see here, well, there's actually a space here, which we can't really see. So maybe we look at the first 7 so that we also get the W from world. So we can see here we've been able to take a subsection. Now obviously, we don't just have to start at 0. We can also start at 1 and take from the first index up to but not including the 7th index, like this. And if we want to go all the way to the end, we can either go up to but not including -1. So that's going to be all the way except for the last thing. And if we want to go all the way to the end, then we can just have a colon here without a final index. And that means we're going to start at index 1 and we're going to go all the way to the end, like here. And something that we can also do like this, but kind of flipped around, if we want to take like the first 5, we can either do 0, 5 like this, but we can also shorthand it by just doing this. It's going to be the same thing. All right, so let me just clear my output here so that we have a fresh screen. Now, another cool thing that we can do, obviously, is when we have these subsections, we can also join them together. So for example, let's say we want to have hello world, which is going to take this part of hello world and it's going to join it together with, well, actually let's have hello LD. So we're going to have this section of hello. We want to keep the space, kind of how that indicated in our variable name, but it's obviously a little hard because we can't put spaces here. And then we want to have this L and D. So how can we use string slicing to basically get these substrings and have that result in this variable? So what we want is we want to go from the first character up to, but not including this W here. Now this W here is going to be our 1, 2, 3, 4, 5, 6, 7. So that's going to be the 7th character. So it's going to be the character with the index 6, which means we want to go up to and including 6, which means up to and not including 7. And then we want the L and the D here. And so what we're going to do here is we're going to take our hello world again, and we're going to go from the second last character all the way to the end. So we're just going to take the last 2 characters. Now if we print this out, and if we just Python 3.9, and we run our main program here, we can see, oh, looks like I included 1 extra character. I messed up on my counting here. Up to but not including 6. There we go. So we have LO space and then LD. So we're going from the first character up to but not including the 6th character, and then we're joining it together by starting at the second last character and going all the way to the end here. Now string concatenation is really nice because, obviously sometimes if you have especially extremely big pieces of information, you want to be able to take subsections, or you want to be able to take out certain sub pieces of them and be able to reuse them. Now, what happens if we don't really know where, a character is? What if we don't know the value contained inside here until we get it? What if there could be a bunch of junk and we basically want to start at the first H? So what we can do is use a really cool inbuilt function that comes with the strings. And what we're going to do is we're going to create a new variable called h_index. And this is just going to give to us the position of the first H that we encounter. And we're going to use this hello world, then we're going to do dot index. Now don't worry too much about this because we're going to look at functions and methods as we kind of progress through this course. But this is just a tool right now that will give us the index of, well, whatever substring we put in here. Now I want to show you this now because we're going through strings, but again, later on we'll go through functions and also methods, and then it will probably be more clear to you what exactly is going on. But right now I just want to show you this functionality. So let's say we want to go and find the index of the first H. So if we print out our h_index variable, and we can see here that value is 0. If we want to print out the index of the first W, and we just change our variable name here to indicate that this is the index of the first W. Again, this is not a necessity, this is just for legibility. We can see here the index of the first W is 6, so it's going to be 0, 1, 2, 3, 4, 5, 6. And we can even use substrings in here. So let's say we want to look at the index the first time, or where we first encounter hello, this substring. This is going to give us the index of where this substring starts. So we're going to say here hello index. This is going to be 1 because we found the substring here, and where it first starts is at index 1. Now if we add an extra L here, then we're not going to get a result because this value was not found within this string. ELLO does not exist within hello world. Now there are 2 cool more things that I want to show you, and these are going to be how we can change things to be full uppercase or full lowercase. So I'm just going to change this back to LLO so that we don't get an error like we have here. And we're going to say, all right, I want to have my hello world, but I want to have it all uppercase. How can I do this? Well, something like we had this index method here available, and again, don't really worry about it too much. There's also another cool thing that's available called dot, and you can already see my environment is kind of showing me all of the options available, upper. And this will transform everything to uppercase. And if I print out the results, we can see here everything has been printed and changed to uppercase. And now if we want to switch everything to lowercase, I'm going to have here hello world uppercase. I'm going to switch the variable name to lowercase. I'm going to reuse, and I don't need to reuse the uppercase here, but I'm going to reuse it because our initial hello world here is actually all lowercase. Or actually maybe it's better if I just add some random casing in here so that we can see the full effects, and we can also use this dot lower method, and then we print out hello world lowercase. We can see everything has been transformed to lowercase. Now obviously, as you already saw, when my environment was kind of doing this recommendations of things that I want to use, there are a bunch of different options available to us, and obviously I can't go through all of them, and a lot of the names will actually be self-explanatory almost to what they are doing, but there's so much cool flexibility that we have also with strings and being able to use and manipulate them. And strings are also going to be one of those core data types that we're going to be using a lot, because obviously text information is something that's very understandable to humans. And ultimately, at some point, we want to have text information because at the end of the day, that's what we're going to be reading and writing with.
Hey there, and welcome back. So in this lesson, we're going to learn about integers and floats, or basically how we can deal with numbers in Python. So previously we've seen strings, which let us deal with text, but obviously a lot of times we want to be dealing with some sort of number, and we want to be able to use numbers and combine them, add, multiply, divide, all that good stuff. So let's go ahead and look at first starting with integers, and then we will look at floats, and of course we'll also learn what an integer is and what a float is. And yeah, let's go ahead and get started. So the first one that we're going to create, or the first variable that we're going to create, is going to be called, or I'm going to call it integer 1. And I'm just going to assign to this the number 1. And so if I print out integer 1, and we just go ahead and run our program again here, you can see here we're displaying the value of integer 1, which is just this numerical value 1 here. Now you'll notice that contrary to strings, where we actually used quotation marks around it, be it either single or double quotation marks, for numerical values we don't need these quotation marks. Now something that's interesting is we can't actually start a variable name with a number. So this, for example, is actually going to throw an error because it doesn't work. So we can see that strings and numbers, or integers and floats, are treated a little bit differently in terms of how we can assign them and how we can use them. So what's really the difference? Well, the difference between these different data types, in this case we had the strings beforehand, and in this case now the numerical integers, is the operations that are defined on them. So for example, in this case we have an integer 1, and let's create a second integer, and this one we will call integer 2, and here we will assign it the numerical value 2. And let's also have two values, which is going to be string 1, so it's going to be the same one as before, which is going to just be the character value, and then we're going to have string 2, like this. So previously we've seen that if we can take string 1 and we add to it string 2 like this, then we know with strings they're just going to be added one behind the other, or they're going to be concatenated. So if we run this, we can see here we get 1, 2, which is exactly what we expect from this, because we have essentially the word 1 and then we're adding to it the word 2. And so putting those two together gives us 1, 2. But obviously for numbers, plus is very well defined, right? Like we know what plus means. We know that 1 plus 2 should be 3. So we can do the same thing down here, but in this case, because our data types are numbers rather than strings, we're going to be doing the numerical plus operation, which is the standard addition that we know. So we can see that although we can represent the same thing in different data types, the data type that we're using is actually important, because the way that these operations here are defined are different based on the data types that we have here. Now something that's also interesting is, although conceptually when we look at it, for integer 1 here we have this numerical value 1, and for string 2 we have this character 2. So conceptually, if you show this to someone, they would probably think that you meant 1 plus 2. But in Python, this doesn't work that way, because on this hand we have an integer, on this hand we have a string, and if we try to run this, it's going to complain because it doesn't know what an integer plus a string means. So it doesn't know what it means to add a number and a word together. And if you phrase it in that way, I'm sure people would also get confused. What does it mean to add a number and a word together? That doesn't really make any sense. And so obviously Python doesn't know that this here contains the numerical value 1, and this one here contains the text version of the value 2, and it's not going to try to do these conversions for us. It just says, I don't know what you mean when you want me to add a numerical value and a text value together. So just be aware of this, that different data types have different ways these operations are defined, and data types are usually not compatible with each other in terms of how these operations work. So for example, we've seen in this case, adding integers and strings together doesn't work. Adding numerical values and text together just is not defined. It doesn't really make sense. So how can we deal with this? Before we go into some of the other operations that you're probably familiar with, like subtraction, division, multiplication, what if we do have, or we know that we have numerical values contained within text? Well, one thing that we can do is we can actually just convert it to an integer. So if we put this integer symbol around it here, so we can say integer and then open and close parentheses around the thing we want to convert to an integer, then this will actually now work because we've taken this text here and we're trying to convert it to an integer like we have here. So in this case it works because we've converted this to an integer. Now don't worry about what exactly this is again, because we'll learn about a function soon, and then this will make more sense as to what exactly the syntax is, and possibly also more what is going on here. But conceptually what is going on here is that we're using this built-in keyword int that is contained within Python, and then we're putting between parentheses this object here that we want to convert to an integer. So in this case we take the word that contains the number 2 and we want to convert it to an integer, and so we do get this defined value here. And if you ever want to look at what type a variable holds, you can actually use this type keyword again with parentheses, and here we can, for example, put integer 1. And one nice thing, just on this side note here, for print, if we put commas here, we can actually just put in multiple variables and just chain those all together. So I'm going to put a print here, and that's going to be the type of string 1. And this comma is basically going to separate these things for us, and it's also going to put a space, which you will see in a second. But if we run this, then you will see here, oh, put another print statement here. I did not mean to do that. Run that one more time. So here we have an integer, and here we have an str, which stands for string. So you can see here, using the type, we know that this one here is an integer, and this one here is a string. And obviously, looking at this, we can also see this, but sometimes you may not necessarily know, because in Python we can actually change the types. For example, what I could do is here, later on I could overwrite this variable to contain a different number, and this doesn't even have to be the same type. And so in this case, we're going to get an error here because this here no longer contains a string. So that's actually something that we have to be careful of in Python, that we can actually overwrite the types like this, and there's so much flexibility that sometimes we can actually run into issues with this. So just being aware of that, we can add strings together like we've seen before, we can add integers together, and we can convert from one type to another, in this case to an integer, using the int keyword. If we want to convert it to a string, we would instead use the str keyword. And here we don't need anything because this is already a string. So we can run this. And then we get the same result because we're just adding one behind the other. And here we can look at the individual types contained within. So let's just look at some of the other operations that we have for integers. So probably aware also of subtraction, and that is also something that we have. So we can run this, we can see 1 minus 2 is -1, so we can deal with negative numbers. We can also do multiplication, like this. So 1 times 2, that's just going to be 2. We can also do division, which is going to be 1 divided by 2, so that's going to be 0.5, 1/2, and we'll get to this in a second because this is actually a floating point number, something that contains decimals, because you'll notice so far with all of the integers, none of them actually contain decimals. So we'll look at this in a second too. And we can also do something called the modulus operation, which is actually just the remainder. It's if we divide this number by this number, what is the remainder that is left over? So, for example, in this case, the remainder of 1 with 2, 1 modulus 2 is 1. And if we do 3 modulus 2, it is again going to be 1. And if we do 2 modulus 2, it's going to be 0. And so what's happening in this operation here, and I'm going to make a comment here, but again, don't worry about this too much because we will actually look at comments soon in a later lesson. What's going on here is the remainder is, okay, we have a number, let's say 3. And if we do 3 modulus 2, then we're going to see how many times can we fit the right-hand side number into the left-hand side number, and then what is the amount that's left over. So in this case, we can fit it in once, so that's going to be 2. And now we can't fit it in again, so that's going to be 1 that's left over. So that's why we see the 1 when we do 3 modulus 2. Now if we did something like 7 modulus 5, so we have the 7 here, if we do 7 modulus 5, then 5 can fit 1 time in 7, and then we have 2 left over, because we can't fit 5 again after we've gone to, so we go from 0 to 5, it fits in once, but it doesn't fit in again, so now we're left with 2. So in this case, 7 modulus 5 is going to be 2. If we do 14 modulus 5, then we can fit in 5 twice into 14, so first going to 5, then going to 10, and then we have 4 left over. And so 14 modulus 5 is going to give us 4. If we do 15 modulus 5, it's again going to give us 0 because 5 fits in perfectly into 15 and there's going to be nothing left over. So this is going to give us the remainder of what is left after we do a certain number, after we do that division. So these are going to be our operations that we can do for integers. And we've actually seen the floating point numbers here in some cases by having, well, these decimal places here. So floating point numbers, just like integers in some sense, are numerical values. So we can have here float 1. And the way that we define floating point numbers is by adding a decimal point, and then we can add numbers after the decimal point. For example, we can do float 1 to be 1.0 and float 2 to be 2.0. And I'm going to take this away so that we don't get distracted by this here. And if I just take all of this and I copy this down here, we can do all the same operations that we could do for integers, also for floats. I'm just going to fill all these in here, and these ones too. And so we can see the results here. Now, the only difference in this case is that we always have a decimal number after the fact. So you may be wondering, all right, well, if I can do the exact same thing with integers and floats, why would I use integers if I could just always use floats? Well, the big difference here is that floating point numbers actually take up a little bit more memory than integers, because we also need to reserve space to represent the decimal values after our main kind of integer component. So just be aware of that floating point numbers take up slightly more memory than integer values do. Now usually this isn't going to be a problem, and most of the time you don't really have that much control over which one you're using, because, and we can see already this above, when we're doing division, for example, Python will already directly give us a floating point value. Even if, in this case, 15 divided by 5 is actually 3, it will still give us a floating point number from here. So just being aware of that, but at the same time also being aware that unless we explicitly use the typecasting, which is what we've done up here, for example, for strings, or if we want to convert, let's say, the result here of float 1 multiplied by float 2, if we want to convert this to an integer, then we will get an integer result like we have here, but otherwise we will get floating point numbers. And generally, if we have integers and integers, most of the time we're going to get another integer. If we have integers and floats, we're always going to get another float. Now, an interesting thing to note, though, is in this case, we've converted the result 2.0 to just 2 here. But what happens if we have a number like 0.5 and we try to convert that to an integer? Well, what happens in this case is just all of the numbers after the decimal are just taken away and we're left with what's at the beginning. In this case, that's just 0. So just be aware that if we're converting from floats to integers, we're essentially losing information. Everything after the decimal point is just kind of tossed away. But, that being said, sometimes, and depending on, we'll actually see this later, sometimes we specifically want some things to be integers, other things to be floats, and so we will do these types of conversions to, make sure that we have that type, because we're not guaranteed that type since, Python is very dynamic in its typing, and a variable can take on different types, and that can also change as the program kind of progresses. So if we specifically want a certain type, then we can use this typecasting to convert from one to the other. But just know that as we're going from float to integers, floats containing more information than integers, but therefore also using up more memory, we will be losing that information after the decimal. So in this lesson, we're going to learn about Booleans. And if you haven't programmed before and Python is your first programming language that you're learning, Booleans may be something that you have not yet heard of, but that's okay, because Booleans are actually pretty cool and you'll get used to them very quickly, and we will use them, or the results, they will often come up as results very often. So in this lesson, we're going to look at Booleans, and we're also going to look at some conditional operations that will give us Booleans. So first of all, I'm just going to create a variable, and I'm going to call that a Boolean true. And this here is going to contain the keyword true. And then we're also going to have a Boolean false, and this one is going to contain the keyword false. Notice that true and false here both start with an uppercase. If I put this as a lowercase, we'll notice this is no longer an actual keyword, but it's trying to find, in this case, the variable named false. But if we use an uppercase F, then auto-completed here, then it will actually use the Boolean value. Now, Boolean values can take on two values, as we can see. We've either got true or we've got false. And now, because they can only take on two values, they actually take up very little space in memory. But most of the time, we don't use them for that. Most of the time, we get Boolean results after we do some sort of comparison operation, which we'll look at in a second. But first of all, let's just print these out. So we have Boolean false, and we also have Boolean true. And let's also display the type of both Boolean false as well as the type of also Boolean true. And if we go ahead and just run this, we can see here Boolean false is false, Boolean true is true, and they're both of class bool. So they're both Boolean values, which is what we expect. So most of the time, we want to use these Boolean values because they show up as results of something. So most of the time when we're doing something, for example, comparisons, and let's take a look at an example, and let's have our just general variable one. And you'll notice that even though I can't start a variable name with an integer, I can actually have an integer if it's not the first character. So you can either have var1, or I can write out var1. This one is just going to contain some random value, which is why I'm very nondescript with the name. So this is going to be, in this case, just the numerical value 3. And let's then have another variable called var2. This one is going to contain the numerical value 5, so the integer 5. So we've seen additions and subtractions and divisions, but if we have two values here and we're not exactly sure what's contained inside of them, because usually when we're programming, we're not defining these values beforehand, but they get given to us either through some input from the user, or most of the time we get this data by looking through files, or also by going to some place on the internet and getting responses from there. But again, don't worry about all of this stuff right now. Just generally be aware that most of the time, although when we're writing the program, we kind of generally know where this information will come from, and we generally have an inkling of what type of data will be contained inside. Usually we can't really be sure of the actual value, or the same variable can take on many values as the program progresses. So we're just at a random point in time right now where we don't really know what's contained within either of these two variables. So now we just want to look at, are the two values equal? So we want to check if variable 1 and if variable 2 are equal to each other. So how can we do that? Well, we have this equal sign, but this equal sign is reserved for assignment, like we've seen above for assigning variables. So if we want to compare and check if they're equal, we can actually do a double equal sign. And so this is our first comparison operation here, and this will check if variable 1 and variable 2 are equal to each other. And if we run this, we can see here the response is false. And that is the Boolean value false that we're getting from here. We can also check if they're not equal to one another, like this, and in this case we get the Boolean response true, because variable 1, which is 3, is in fact not equal to variable 2, which is 5. We can also do other operations like greater than or less than, where we check if one variable is, in this case, greater than variable 1 greater than variable 2, or variable 1 less than variable 2. So we can see here variable 1 is not greater than variable 2, so the response here is false. And if we look at variable 1 less than variable 2, the response here is true. We can also chain this to not just have greater than, but we can also do greater than or equal, or less than or equal. The important thing here is that the equal sign is the right-hand side, and then the comparison greater than or less than is going to be the left-hand side. So we have two values here, and we can see a general trend here. We've got double equals for to check if they're equal, exclamation mark equals for not equal, greater than equal for if it's greater than or equal, less than or equal for if it's less than or equal. In this cases, our responses are going to be the same, because the greater than or equal won't really apply, because it's always either greater than or less than. We can see that in each of these cases we're actually getting Boolean values returned to us. And we'll use this a lot later on, but a lot of stuff that we're going to be doing in our programs is going to be these sorts of comparisons, and maybe a little bit more complex comparison logic, but most of the time it kind of comes down to these basic operations where we're doing some sort of comparison, and then we want to see if certain conditions are either true or if certain conditions are false. Then we want to do specific things. So being able to do these comparisons is very useful, and this is most of the time where these Boolean values show up as the results of these comparison operations. Now, be aware that not all operations are going to be defined across all the different types. So in this case, if we have the integer 3 and the floating point number 5.5, everything's going to be fine, because these are both still numerical values and these comparison operations are defined for each other. But if we then come back to strings, which is another type that we've learned about previously, we can see here, okay, so the comparison of if they're equal works. We see that they're not equal. The comparison of them not being equal also works. We can see the response of variable 1 being not equal to variable 2. The response here is true. They're not equal. So in this cases, we can compare these two data types, but we can't compare them in terms of greater than or less than, because again, it doesn't make sense to ask, is the number 3 bigger than the word 5.5. It doesn't really make conceptually sense. And so in these cases, it's going to throw us an error. So just be aware that some operations, specifically the comparison of equality or not equal to, this can usually go across data types. But other operations like greater than or less than and greater than or equal to and less than or equal to, these are going to be specific within the same data types.
Now, another interesting data type that will pop up very often when you're actually working on projects in a company is going to be the none data type. So let's create a variable for it. We'll say var that is none. And the none data type is written out like none, just like we have for the booleans with true or false, but it here has a capital N. And if we just print out the variable, as well as printing out the type of the variable, we're going to see its value is none. And its type is the none type. So the none type is interesting because it's very, very often used to just indicate empty or missing data, however that may be defined. So sometimes when you're trying to read something in and then there's nothing to read, the value would just be empty. So you could either have it be an empty string, but maybe you also want to, depending on the situation, actually represent this as a none value. And there are also other situations, and essentially just every time we don't have data that we want to have, but we are still storing this as a sort of like placeholder, or just to indicate and be able to have history, and then we notice that certain things are just not there, whatever the reason may be, none pops up very, very often when you're actually working on the programs, just because it's likely that things are not there where they're supposed to be, or maybe you can't get the information from somewhere because the service is down or the connection to it is not working properly, or whatever the reason may be. At some point, things just don't work as expected and some of the values are not there. And so we have the none type for that, which basically just indicates to us, rather than, having some sort of issue, saying something isn't there, we can just say, all right, well, it's empty. And then it's kind of up to us in our program to define what exactly that means and how exactly we can deal with it. Now, generally, we've looked at comparison operations and the like, but for none types, it's not necessarily that useful, because really the only thing we want to check is if something is none or if it's not none. That's basically like the only check we would make, right? Is it there, is it not there? That specifically is something that we're going to look at when we go into the if, elif, and else statements, because we're going to be doing parts of the conditionals there. But yeah, just being aware, this none type is another data type available to us, and it does pop up very regularly, but that's totally fine. We just need to be aware that it's there and, account for it and treat it properly. So now that we've seen some of the more basic data types in Python, we're going to look at some of the more complex data types that will really allow us some flexibility in what we store and how much we can store in one place, and really allow us to bring our programs to the next level. Now, the first data type that we're going to look at here is called a list. So let's take a look at that. So we're going to have our variable here that we're going to store it in called example list. And if we want to store a list, we're going to use the open and close square brackets like this. Now what we have here, if we print this out, is we have an empty list, and let's also print out the type so that we can take a look at its type of this example list. And let's go ahead and run this. So we can see we have an empty list, which is also how it shows up here, and the type here is of class list. All right. So into this list, we can actually start putting in elements, and we can have different elements separated by commas. For example, let's say we want to have a list that contains 3 elements. The first one is going to be the integer 1. Then we're going to have the second element 2, and the third element 3. Notice that the different elements are separated by commas here, except for the last one, after which there is no comma. So now we have a list of 3 integers, and if we run this and we print it out, we see we've got 1, 2, and 3, and again, the type here is still list. One more cool thing that we can do here is we can actually use this built-in method called len, which stands for length, and this will give us the length of, well, whatever object we put inside.
So for example, if we put in our example list and we print out the length, then we're going to get 3 because there are 3 elements contained inside. So we've got the list, which the first element is 1, the second element is 2, the third element is 3. It's of type list, and there are 3 elements inside. The list is of length 3. Now, we don't just need to have integers in here. We can also have floating point numbers, 1.1, 2.093, and 3.11111. So if we run this, we can see this works fine too. The length hasn't changed because we still have 3 elements, but the values inside have changed. Now, a cool thing about lists is we don't even need to have the same types. So for example, we can have floats and integers inside. This works. We can have floats and strings and integers contained inside. We can also add another variable. Let's make it a Boolean. Now our length is going to change to 4. But we can see here we're not limited to the type that a list contains, which means we can really use it to store anything. And it's extremely useful because it allows us to keep track of information that needs to be grouped and be able to use all of that together. But usually when we're using lists, we don't initialize, and this is what it's called, we're kind of giving it a value. We're not declaring it in here specifically with a set number of values, but usually what happens is we would have an empty list, or maybe a list with like a preset number of values, and then we want to add to that list maybe, or maybe we want to remove some values, but let's look at adding first. So starting with our empty list again, let's go ahead and add a value. So we're going to have here example list, and to example list we want to add a value. So the way that we can do this is we can use the .append method. Now we've seen the built-in methods before, like upper and lower, and again, don't worry about this too much because we will look at functions and you will understand the syntax a bit more, but right now it's still important to see how we can use this and what effect it has. So if we just print out the same value, so if we put in here a 1, now we want to append the value 1 into our list. So what happens when we run this, we can see that the value has been added into our list. So before we had an empty list, but now with the .append, we inserted this element into our list here. And we can add multiple values. So we can do something like this. And this will add multiple values into our list like this. Now again, most of the time we're not going to be writing this out explicitly like we have here and kind of adding preset values, and as we will learn later, when we have loops and we can use files or data from other places, then we can get that data from somewhere, and then we can go over our data and we can kind of add in these components, maybe based on specific conditions, like we will also learn, but like we've already hinted towards when we looked at Booleans. But we can see here that we can add elements into our list like this. All right, great. So we have these elements in our list, but what can we do with them? So just like we've seen for strings, and actually as a quick side note, this len method here also works for strings. So if we print out len of the hello world string, and we'll just quickly run this, we can see here it contains 11 characters. So we've seen this for lists, but this actually works for strings too. And another similarity, like we've seen before, is the indexing. So we've seen the indexing with strings, and we actually have the indexing too with lists. So let's take our example list. And if we want to look at the first element, that's going to be the element with index 0. We've already seen how to do this with strings. But we can do the same thing here, and we'll get the first element, which is going to be the first element here, which in this case is the integer 1. If we look at the second element, the element with index 1, it's going to be the string 1, this one here. In the output, we can't see the difference, but they are different. This one's the integer, this one's the string. If we want to look at the last value, just like we did before, we can access by -1, which is going to give us this value here. Now, note that unlike strings, where when we accessed a specific index, it will give us just that specific character, for lists instead, when we're using indexes, we access the full element contained in that place. But also here, if we try to access an element outside of the size of the list, for example with index 3, then we can see here we can't do this because the index is out of range, since index 3 would be the 4th element, but our list only contains 3 elements like we have here. But also here, and if we just want to add a couple more values, so let's add in test, and here let's add in false. We can do the slicing that we've seen before, where we take a subsection. For strings, we've seen it as a substring. For lists, we can see it as a sublist. So let's say we want to take everything from the second element, so the element with index 1, up to, but not including, the element with index 3. So that's going to be the element with index 1 and the element with index 2. So the second and third element. And if we run this, we can see here we get a smaller list that contains, starting from the element with index 1 up to, but not including, the element with index 3. So from here up to, but not including this one, so it's going to be these two here. Of course, we can make this bigger if we want to, or we can go all the way to the end if we want to, just like we've seen with strings, or also we can start at the very beginning and go up to certain thresholds, again, just like we've seen with strings. Now, in some cases, and we've seen before, for integers and strings, we have these additions defined, and we can actually have additions between lists too. So we have our example list here, and let's take an example list 2. And this example list 2, we're going to take our example list, and we're just going to take a subsection of this list. So if we print this out, we can see here, this is our example list, and this here is our example list 2. All right. So we also have plus operations for our lists, and let's call this here concat. Oops. Lists is going to be our variable name, and we're going to do list1 plus list2. And what this does, very similar to strings, it just sticks them, well, we didn't print it out, sticks one at the end of the other. So it concatenates them together. So this is our example list. This here is our example list 2. And now this one here has been stuck to the end of this one, and it forms one bigger list. And if we also want to print out the length here, then we should get 7. It's going to be 1, 2, 3, 4, 5, 6, 7. Exactly the number of elements we have contained within our list. Now we've seen this plus operation a lot, and there's usually a shorthand for this. So in this case, let's say that we want to have our example list, but rather than saving this in a new concat list variable, we just want to update it. Let's say we have our syntax instead like this, because we don't want to create a bunch of new variables, but rather we're going over a lot of data, and we just kind of want to have this one list where we keep track of things, and we just want to update it. So in this case, we're going to get the exact same result. So we're just going to overwrite the value contained in here, and it's going to use these two values. So this value is defined. It's what we have from all these results here. This one is defined, comes from here. And so we're going to take these two together, and we're going to save it in here, which is going to overwrite the value contained inside here, as we can see. So when we have this sort of notation where we have the same thing on the left and on the right side, and we're just adding something to it, what we can actually do in this case is use a shorthand. So instead of writing that, we can do a plus equals. And this is going to do the exact same thing. It's just a shorthand for what we've seen before. So if we just undo this, this here, this example list plus example list 2, because we have the example list on both sides, is the same as just using the plus equals. Now, in this case, we've done it for lists, but the same thing applies for integers, strings, floats. We can have the plus equal. For integers and floats, we can also have the minus equal, the multiply equal, the divided by equal. All of that is also valid, and they're all just shorthands for when we have the same variable on both sides and we just want to update it. Rather than, saving it in a new variable, we can use this plus equal, in this case, operation. Now, what happens if we want to remove some values? How can we go about doing that? Well, there are different ways that we can go about doing this. One way is we can just take a sublist. So let's say that we want to remove, the first two elements. Well, what we can do is we can just overwrite our list and say, well, all right, our new list is going to be everything starting from the element with index 2, which is going to be the third element. So in this case, we're basically just overwriting our list. Another thing that we can do is we can use an operation called pop. Again, that's inherent to the list, and this is just going to remove a specific index. So for example, if we want to remove, and notice here that we've taken the subsection of the list already, so this is going to be our last value. Let's say we want to remove this false value. So the value at index 2, the third element. We're going to put in here a 2, and then let's print that out. And we can see here this value has now been removed from our list. Now interestingly, the pop actually returns the value. And again, don't worry about this too much because when we look at functions, you'll understand what that means. But basically, when we use this, this is removed, but we still have access to it. And we can assign this value to this right-hand side component, and we will see that this value is the value that was removed. Now this is useful in cases where you have a list where you want to extract values one by one, for example. So you can just take them out one by one and kind of save the result and then continue on using them. Again, don't worry about this syntax too much because when we get to functions, we're going to look more in detail about what it means to, have this braces syntax as well as what it means to assign a value to something that may come from it. So again, don't worry about this too much. Just be aware that this exists, and when we look at functions later on, hopefully this will make more sense to you then, or the way that the syntax is written will make more sense to you then. Now, another really neat thing about lists is we can actually store a list within a list. So let's take our example list here, which we've printed out, which is now this, and let's reassign the last element, or let's reassign, we'll reassign the last element. So we're going to access the last element, and now we want to overwrite it. So we can do that by just accessing the element with a specific index, and then we can assign it a new value. So quickly just doing this, and then we'll look at the list within a list. We can see here we've been able to overwrite it. So now, rather than assigning a specific value, like a string, for example, let's assign just a full list. So we're going to take our example list. We're going to access, in this case, let's access the last element again. And here we're going to assign it a new list. Let's say the list 1, 2, and 3. Now, usually, just as a quick side note, when we're writing lists, you want to have spaces after the commas here. That's just good formatting. It won't change anything to how the code runs, it just makes it a little bit nicer to read. So we're going to run this again, and we can see here the last value here is now actually a list in and of itself. And if we access the last value, we will actually get that list. And then here we can use the indexing again, because this is again a list. So let's say we want to access this number 2. Well, to do that, first we have to access the last element here, which is either the element with index -1 or 3, so 0, 1, 2, 3, or -1. This is going to give us the same value. And then we want to access this element here, which in this list is the value at index 1. So we can see here we're first doing indexing on the first list, and then we're doing indexing on the second list. This is going to give us that number 2, since we're picking out this element, and then from this list we're picking out this element here. So we can see we can have lists within lists, and these are called nested lists, and we can always still use our indexing syntax like we have, and the same rules apply, and we can still access the elements within there and be able to use them, update them, manipulate them, and all of the other good stuff that we've seen. All right, so we've just seen lists. Let's go ahead and take a look at another cool data type called a tuple. Now, in many ways, as we'll go through the tuple, you'll see, wait a minute, this is actually pretty similar to lists. Why would we use one versus the other? Or in fact, why would you use tuples at all? So we'll talk about that in a second, but let's go ahead and take a look at this first. So let's create an example tuple. And the way that we can create an example tuple is by using open and close parentheses. And just like within a list, we can now add elements inside. Let's leave it as an empty tuple first though. Let's print this out, and let's also print out its type like this. And let's go ahead and run that. And we can see here the result is an empty tuple that we have here, and we have open and close empty parentheses. Now, don't get this confused with the the open and close parentheses that we've used previously when we did the pop, the upper, lower, and even the type and the length and all that stuff. This is actually different. Again, we will see this when we get to functions. It just happens that they use the same parentheses in some cases, or in some locations. So we have our tuple. So just like in a list, we can have values in here. So you can have elements 1, 2, and 3, for example. And this will give us a tuple of length 3. And again, here we can also use this inbuilt length method that is available to us, and we can look at the length. So you can see here it has a length of 3. It contains 3 elements, and also here we can look at the example tuple, and we can take a certain value. Let's say we want to take the second value, so the value at index 1. We can print that out, and we can do the general slicing that we're familiar with. Now, the interesting thing about tuples that's different from lists is that we can't change tuples. We can't add more values to them. The size of a tuple is fixed. Now, you may be wondering, okay, well, why would I ever want that? I can use a list, I can add in values, I can remove values, whatever way I want. Why would I want a tuple where I can't add or remove values? And it's only ever going to be these here, and I may be able to update them, but I can't change how big it is. Well, in this case, it's important to remember that programming is not just about, giving things that the computer can understand, but also it's about making things very usable for the humans who are programming the programs. Because it's a lot of issues, basically all the issues that happen is when humans make mistake. They write or they create bugs in their program. There's some sort of error, or either a logic flaw or some sort of syntax error, like we've seen in some cases it complains, or you didn't consider an edge case. But basically, most of the things that go wrong almost all the time is because a human had made a mistake. And so there are tools in place that we can use to help us combat these mistakes. And we'll look at this a lot more when we actually start building out the application, because we need to be conscious about these things. Right now we just kind of want to learn the core things that we need to actually then get started, doing some cool stuff. But we need to first learn some basics, walk before we can run. So the tuple is one of those examples where we know how much information is contained within each. We're essentially guaranteed that. And so if we use tuples, then we can know that there is going to be an index 0, an index 1, and an index 2 in this case. And most of the time, if we use them, we actually would also use them in such a conceptual way that each of these elements corresponds to a specific value. So for example, we can have some person information, and this here can be their name, let's call them Ted, their age, let's make them be 26, and we can have them be the country that they live in. We can call that US, for example. So if we print out person information, we're going to see these results here. And now essentially, although there's better ways to do this, there's still structure in here about, well, we know there's going to be 3 pieces of information contained with the person information. And generally, and now we're kind of making assumptions that we have and other people have followed this format, that the first one is going to be the name, the second one is going to be the age, and the third one is maybe going to be the country where they're currently living or something like that. But it gives us a little bit more structure. And the flexibility of lists is, of course, super awesome, and most of the time you will be using lists, but in some cases you may realize, like, hey, actually, the behavior that I want here is more that of a tuple than a list. And so I'm going to use a tuple here just because, it may not change anything in the code, but it will just add this extra little bit of protection to, make sure that when I expect something that has 3 elements, not something that only has 1 element comes in, or something that has 20 elements, I just want to make sure that what I'm expecting is what I'm getting. And if people are using this correctly, and if I'm using this correctly, then this thing should always contain 3 elements. But of course, although we can't add to tuples in that way, and if we try to do an assignment, so for example, let's take person information 1 and let's change their age, then we can see here the tuple object does not support item assignment. So once we have this tuple defined, we can't update it. That doesn't mean we can't use them to create new tuples. It's just an existing tuple that can't be changed. But if we want to have here our person information, we'll call it person information clone. And let's take the person information, and to it, we're going to add the second and all the way to the end elements here using the slicing syntax that we've seen both for strings and lists already now. We're going to create a new tuple that we can print out, and this tuple is going to be of length 5. So we can create new tuples and we can join tuples together. We can't update existing ones. Now, one more thing to note is when you're creating a tuple of length 1, unlike lists where we can do something like this, a tuple of length 1, you actually need a comma after it. Now, for everything after length 1, you no longer need that comma after the last element, but if it's a length 1 tuple, then you do need that comma after the first element. So just be aware of that. If you ever need a length 1 tuple, then you have to have that comma after the first element, but everything after length 1, for example here, we do not need another comma after here. It's only when our tuple is of length 1. All right, now we're going to look at another cool data type called the dictionary. The dictionary is very useful, and it's likely that you're going to be using it a lot. And essentially, it allows us to create mappings from one key to another, or one key to a specific value. But we'll see what that means in a second. So let's create our dictionary, and let's first have a variable for it. So we'll call this our first dictionary. And to initialize a dictionary, we're going to have the open and close parentheses, curly parentheses, or the curly braces, like this. And then let's just have the default printing out our first dictionary, as well as also the type of our first dictionary. And go ahead and run this, and we'll see that this is an empty dictionary currently, and the class is dict for dictionary. All right. So what can we do with this? Well, we saw that for a list, we can basically kind of add values into it, and we can have this nice structured order of things. For a dictionary, generally a dictionary is not ordered, and you should not think about order in a dictionary. In Python, it has specific implementations that there are ordered dictionaries, but generally it doesn't matter what order you create keys, and we'll see what keys are in a second. Essentially, you should not assume that when you put something in first, that is also the order that you're going to have it at the very end, because dictionaries themselves are not reliant on order and are usually not used when ordering is required. So the structure of a dictionary is basically we have some sort of key, which is
going to be defined here, and then we have some sort of value that it points to. And so within a dictionary, we have always key value pairs like this. If we want to have a second key, we can have here key 2, and this is going to point to value 2. Now notice the structure here. So we have on the left hand side our key, which in this case is a string, but we'll see in a second we don't need that. Then we have a colon, and then on the right hand side we have the value here like this. And then we have a comma, and then we can add in more keys and values. Now we don't need to have this on separate lines, we can have this on the same line too, and then we can have it, more on the on separate lines. But essentially, and you'll see this usually in your coding environment, there's going to be some sort of line, which just means that you don't want your lines here to get too long in the horizontal. So you want to be able to kind of break them up over multiple places. And what we can do in a dictionary is just always do that on commas. We can do that too for lists, by the way, and everything. But again, most of the time, we're not going to be initializing this. Although for dictionaries, sometimes we do initialize it because we have some sort of preset mapping that we want to use. But most of the time, we may just populate this as the code runs. So here we have two string values, or one key and then the value, and then another key and the value. Oh, it should be value 2. But we don't need strings here. We could have an integer as a key, and then we could have an integer as a value if we wanted. We could have an integer as a key. We could have an integer as a key, and we could have a string as a value. The one important thing though, and you saw me just correcting that, is keys need to be unique in a dictionary. So let me just quickly run this. And if I try to use a key that already exists, well, something weird happens because now we've basically just overwritten our key, as we can see here. But keys cannot exist as duplicates. So it's very important that when you think about dictionaries, every single key needs to be unique, and you can't have duplicate occurrences. So let's remove this because this behavior is actually pretty confusing, and I would never recommend doing something like that in code because it will confuse everyone who looks at it, because the behavior can be unpredictable. Even if Python has a specific way of handling it, looking at it, and if you don't know exactly how Python handles it, it's weird because dictionaries have to have unique keys. But we can see here that, again, we don't need just strings. We can have integers, we can have floats if we wanted to, as long as every single key is unique, and we can point from one value to another. So the cool thing about dictionaries is that we can then access specific values. So if we go into our first dictionary here, and let's say we want to access the value contained within key 2, which would be value 2 here. So we can just access the value here, key 2, and if we run this, we're going to see that we get the value printed out for it. So this is, again, why it's kind of akin to a map. It's basically like some sort of lookup map, right? We have a key, and then we say, okay, we have this key, what is the value associated to it? So an easy example for this maybe is if you're calculating sales tax or VAT, you can have specific country codes, and then you can have, not exactly sure what all the VAT values are, but you can have mappings to whatever those numbers are. And then basically, if you're processing taxes, for example, then you say, oh, okay, I've got this invoice from this location, and it's from this country, and what is the VAT amount that I need to add? Oh, it's 19, so this would be 19. You have to interpret it as a percent. It could be 1.19, which means you multiply it by 1.19 again to get 19%, but whatever it may be. So in this way, we can very easily look up, okay, this country flag points to this value. And this country flag is usually what you have in invoices. Either you would have this, or you would have Germany written out, or you could have both of these in there because maybe the way that the invoices are generated are not consistent, so you need to support both options. But either way, we can very nicely use maps because we basically know, okay, this kind of maps to that. So in this case, this would be more of an example of a predefined map. In other cases, again, we will be determining and creating these dictionaries as the code runs. And we can also use it to keep track of information just like we can for lists, for example. Now there are some more cool things with this though. So in this case, this wouldn't run because the key 2 does not exist in the dictionary. So we need to make sure that we're accessing a key that actually exists. So we can see here we have this lookup value here. So how can we add new values into our dictionary then? Well, it's pretty simple. All we have to do is take our dictionary. So I'm going to just copy this name here. And let's say I want to add another value, and let's just have this be, I don't know, some random letters here. And we're going to map this to some more random letters. And so in this way, we can create a new key in our dictionary and we can assign it this specific value. So we can see this key has now gotten added into our dictionary, but we can also do the same thing to overwrite. So let's take this key here, and instead of creating a new value, or maybe we do this here, overwrite value. So we can see here we're overwriting what's contained within this key. So depending on if the key exists or not, we're either creating it anew or we're overwriting it. Now the nice thing is, again, we can use variables for this too. We don't need to define this here, so we can have some example variable, and this is going to take on the key here. And so we can also just use the variables, which is usually what we'll do, because again, variables are going to be how we're keeping track of all of our data, all of our information as our program runs. So we'll pick it up at one place and then we can use it later on like this. So how can we do the opposite? How can we remove a key? Well, all we have to do here is we're going to use a new keyword called del for delete. And then we're going to have the dictionary and as the key here that we want to delete from it. And then let's go ahead and print it out afterwards again. And so we can see here, the key has now been removed from our dictionary. Now, just like we've seen for lists, for example, we can also have nested structures in our dictionaries. So let's take our dictionary here, and we're going to create a new key, and we're going to call this nested dict. And we're just going to call this, again, this is a string. Our machine doesn't really know what this means, just it's a series of texts, but this is just for readability for our sakes. You could call this anything you like. And this key could even be, an integer or float or whatever. But I'm just going to call this so that we, kind of have that legible component. And I can assign a new dictionary here. So we can have here new key and value, and then we can even reuse keys that we have in the higher dictionary. So the key uniqueness is on the dictionary level, but if we have a nested dictionary, like we have in this case, then as we can see here, we can reuse those keys because the key has to be unique within the dictionary it's in, and so it's in here, and within this dictionary, this component here is actually the value, and it's the value of the nested dict key. So we can also have nested dictionaries if we want, just like we can have nested lists. And here again, we saw just a dictionary within a dictionary, but we can also have a list contained inside there too if we wanted. So let's just create a list here. And run that so we can see we can store all sorts of information in our values here. The one thing that's important that we shouldn't be doing is thinking about using these complex data types as keys. Rather, we should stick to the simple data types and have those be our keys, and then the complex data types, those can be our values. Now, just like out-of-range indexing is a problem for us with lists, accessing a key that doesn't exist is going to be a problem for us with dictionaries. So if we take our first dictionary here, and we try to access the key K, which does not exist, it's going to complain because the key does not exist. So in this case, there are different ways that we can go about it, and usually what we're going to be doing is having some sort of, one way is we could have a conditional. Another thing that we could do is rather than accessing the key directly to get the value, we can actually use another built-in method called get. So we can have our dictionary here, we can do .get and then the key. And if we run this, then instead of throwing an error, we're going to get the none. So basically it's going to try to get the value k, and if it can't find it, then it's going to return this none to us, because the none is the default value. But we can actually also overwrite that default if we wanted. We can say, try to get k from the dictionary. If it exists, give us the value, and if not, give us this default value, which I've just set to be v. So we can see here, we can then return a specific default if the value does not exist in the dictionary. Now, if we want to add it in and try that again, just to see how that would work. So the first time we're going to get the default value returned because it does not exist in our dictionary, but the second time we have added the key into our dictionary, and so in this case we're actually going to get the value contained within the dictionary. Now this is nice when we're getting values, but sometimes we also want to just do operations on things. For example, maybe our dictionary is just a way for us to kind of have counters for different things that we're keeping track of. And so something that we want to do is we want to, every time we encounter something, we just want to access that value and we want to increment it by a certain amount. But it's likely that if we start our program, we may not know all of the values that we're going to encounter. And so what happens is we would initially run into an error where if our dictionary is completely empty and we want to, we encounter a value and we want to increment it by 1, then we're going to get a key error because the value is not yet set in the dictionary. So one thing that you can do, which we haven't learned yet, but when we look at conditions later on, like writing if statements, for example, you can write an if-else statement where you say, if the value is within, then we do this, and if not, then create it, and then we can do it. But that's usually not super pretty because it requires several lines of code. And so something that we can do is we can actually use another built-in method. And again, we've been using a lot of built-in methods because they're good to learn as we're covering these data types rather than retroactively going back to them. But once we cover functions, the built-in methods and just general function structure will make a lot more sense to you. So there's a method here that we can use called setDefault. And so this way, let's have a value t here. We can set a default value for t if it does not exist. So let's go ahead and print out our first dictionary before and after this. So we can see here the value is not contained within. Then we have the set default, and then the value is contained within here. If the value already exists, let's do the same thing here, but let's set t equal to 1, for example. Then it's not going to overwrite it. It's only going to place it in if the value does not exist, as we can see here. But the value already exists, and so the set default has no effect because the value is already in our dictionary. So this is usually nice because we can use it in combination. For example, we can have our first dictionary and we set the default, and then we can access this value here and we can increment it by 1. And this way we can be sure that the value is contained within our dictionary and we don't have to have these specific checks like if the value is inside, then we first need to initialize it, set it to 0, otherwise, and then we can increment it by 1. This is just a little bit cleaner way of doing this, and it's a little bit, it's a fail-safe because nothing will happen if the value is already inside, and if it's not, then we're going to set a default value that also kind of guarantees consistency for us, that the default value that we're setting will be the same for every new key that gets added into our dictionary. All right, so in this lesson, we're going to take another look at the print statement that we've been using throughout, and also just see how we can integrate some variables easily for formatting, because that's actually something that comes up very regularly, and I'll show you in a second how, as well as also how we can leave comments, because these are especially useful either for us as we're kind of just leaving notes for ourselves while we're programming to, tell us about things that we should get back to, or also when a project is done. In some cases, when things require special knowledge about, why something is done the way it is, or how something is working here that isn't particularly obvious, it can be helpful to leave a comment to describe what you're doing or what the purpose is. Obviously, your code shouldn't have comments littered everywhere because that just makes it incredibly hard to read. But if you do need a comment, then, obviously don't shy away from adding it. All right, so first we're just going to take a look at the print statement. And what we're going to do is we're going to create a variable, and we'll just create a name that we're going to have in here. So for example, let's say Ben, and let's also give Ben an age. It's going to be 22. Now, something that can happen either when you're writing the program and you just want to test how a certain state is. For example, the name and age can take on many different values as you're iterating over a list of users, or also just you just kind of want to see what state you're at. You want to see like what is going on right now. In those situations, it's very, very common to just put print statements throughout your code to actually show you what the current values are. Especially right before things are crashing, you want to know what values do I have right now and what is causing this to crash. So in this case, we have the name and the age, and one way that we can put it out is, or one way that we can print it out is actually putting the name in here and then the age in here, and we can actually just separate these variables by commas, and then they're going to just print these out one by one for us. So let's go ahead and run this, hit enter here, so we can see here Ben and 22. Now obviously, we kind of know what's going on here because we have very little code and we have the one print statement, but this isn't as helpful. Something that would be a lot more helpful is even just adding a little bit of connotation here. For example, is and age. And we also see every time we add a comma in here, we just get a space for free. So something the print statement does here is just helps us with formatting. So if we run this again, we can see here Ben is 22, which is a little bit more clear because now obviously we get some context. Now this sort of printing is pretty good, when you're trying to communicate someone to just a user. But if you're doing the debugging yourself, it can also be extremely useful to know what variables you're using. So for example, in this case, I want to know like what is this first variable that I'm even looking at? What is the second variable? So maybe something that you'll do is something like this, where you'll print out the variable name as an actual string, and then the variable value directly afterwards. So now I know when I see this, okay, this is the variable name, and this is the variable age, and these are the values contained inside. Now, obviously we can do it like this, but then we have this mixing and we always need commas, right? We need a comma here every single time we separate from a string, and then we have some variable that we can put in here and another string and another variable. We always need commas to separate these. Or something that we could technically also do is use our string concatenation. So this is going to be a string, so we don't need to cast it, but just to be safe, we'll cast it to a string anyway, because technically this could be anything. Then we'll use another plus, but now we have to make sure that we add spaces here so that we have some proper formatting, and then we can do a plus here and cast this to a string and run this, and then we get the same result. But obviously this is not nice at all because we're just, we're doing a lot of work casting to strings, doing pluses here. Maybe we have a typo here and then we run something and then, like 2 minutes later it throws the error that actually there's a typo here because we've put a bracket like this by accident, or, something weird like that. So there's a much nicer way that we can integrate variables and strings directly with each other, and that is called through using f strings. So what we can do is when we have a string, we can put an f in front of it, and then we can use open closed curly braces to put in the variables, and these variable values will be automatically inserted for us. So for example, let's reproduce what we just had. So we're going to say name and then the value of name, then we want to have age and the value of age. And if we run this, we can now see we have a name with a colon here and a space, exactly as we have it here, and then the value gets inputted in here, and then we have the space age colon space right here, and then we have the value that's formatted for us here. And it doesn't matter that this is an integer, we don't need to convert it to a string. It's all kind of taken care of for us and we just get this really nice clean output. This is extremely useful because it just saves you a lot of time, and likely you'll also be making less mistakes when you use these F strings for formatting than if you're trying to do it by hand using some casting and string concatenation, or sometimes your outputs will look weird if you're using a bunch of commas, or maybe you're not, really getting what you need. But also in some cases, when you're serving other purposes, for example, you want to print something to a user, or you want to do some sort of a logging just to have a log of whatever happened, you want to be able to, do that easily. And not everything works like the print method that we have here. Not everything just accepts a bunch of commas where you can put in a bunch of things. Sometimes that doesn't work, so you actually have to create the string yourself. Now the nice thing with the F strings here is we can just have this as an actual string. So we can save this in a variable and then print the output text. And even if our method here does not accept just a bunch of commas that let us add on extra things like the print statement does, we'll still be okay because it's just a single variable, just a single string that we have here. So that's just going to make it really, really easy for all the string formatted output that you're ever going to need, be it for printing, be it for logging, be it for users, be it for inserting into databases. Whatever your use case is, using the F string here is probably just going to make your life a little bit easier and just, make your code a little bit shorter and also just easier to read, which is always the best thing. Now, there are also some cool things, though, that we can do with formatting, specifically to things like integers or floating point numbers. So let's say we also have a zip code. And let's just give this numbers 1, 2, 3, 4. But zip codes are usually 5 digits. So what we want to do is we just want to always be printing out 5 digits. So we'll say lives in, and now we want to have the zip code. Now if we do it like this, unfortunately here we're going to have 4 numbers, but a zip code will always have 5. So what we want to do in this case is we just want to have a placeholder 0 in front to make sure that we have 5 numbers. So if we have less than 5 numbers, then we'll have that placeholder 0. And if we have 5 numbers or even more, which in the zip case wouldn't make sense, but just speaking generally, then we're just going to print out the exact number that we have. So the way that we can do that is by adding a colon here and then doing 05D. Now there are a bunch of little tricks that you can do, and we can see here now we just have this 0 printed in front. If you ever encounter a situation where you're like, this output looks like this, but really I need it formatted in a different way that's more specific. For example, I need some sort of consistent indent. I always want to have the same length of characters, or I want to have it, in this case, formatted with a leading 0, or I want to have like spaces here. Whatever your use case may be, the easiest thing that I would recommend is just, doing a quick Google search, and you're going to find your answer very, very easily and very, very quickly. You're going to be able to use these F strings to just put that value in there and do the quick formatting. And yeah, your F strings are going to help you a lot with just having all of that formatted text. Now, another thing that we can do, and let's just turn the age here into a floating point number, is, or maybe we'll have it something like this, is just another example here, changing the precision of our floating point strings. So for example, let's say we don't want to, print out all of these 3s, but really we just want to have 2 decimal places. So what we can do here again is we're going to say .2f, and essentially that means we're going to have 2 decimal places after the dot here. So if we print this out, you can see here we've got the first 2 numbers, and then we have the decimal place, and then we've got 2 numbers after the decimal place, and then all of those extra ones are just taken away. And so obviously all of this stuff is going to help us with just having some really nice formatting. And again, this is useful both if you're showing stuff to users or if you're putting stuff into a database, but also just, if you need to have some sort of a logging, putting this all together and having it formatted properly is going to make it so much easier for you to come back and revisit and try to understand the state that your program was in right before it crashed so that you can understand what happened and maybe how you need to adapt your code to make sure that doesn't happen again. Now, the other thing that we want to talk about quickly is comments. Comments we can very easily put in by having this hashtag, pound, or whatever you want to call this symbol, and we can just add in a comment. Everything after this hashtag is going to be commented out, which means the user can see it, but your computer is not going to look at it. It's just going to skip over it and not consider it. So for example, if I type in here, print A, all of this is going to be ignored. It's not going to change anything. Even if I have bad code in here, that's not going to work. We just skip over it. So comments are nice because generally we can describe our specific thought process. Now, bad comments are something like, here we're creating a formatted string with the user's name, age, and zip code. This is a really bad comment because we're just stating the obvious and we're not adding any value. And most of the time, you don't really want to add comments to your code because most of the time your code should be clear enough in the variable names that, and later on also in the function names, that you should be able to understand what's going on. But sometimes there are specific things in the business logic, or there's actually a specific hiccup in some of the data that you're receiving, or there may be a bunch of different edge cases or conditions or just things that you want to consider that even when you look at the code, it's not clear because something particular is going on. In those cases, it would be really great to leave a comment to describe why something is the way it is. And in those cases, having a comment like this, and a comment can even span multiple lines, and something that I actually like to do is you can use the command or control, depending on if you're on a Mac or Windows, and the / together, and it's automatically going to just comment the line if you're in PyCharm. Most other code editors have the same command or control and then the /, but if you're using something like Anaconda Spiders, then that may be the command or control and then one together. So you're always going to have a hotkey that's going to let you do this automatic multi-line comment, but it may differ depending on what code editor you're using. For example, let's say I have a comment here. This is my comment. And then we'll have here second line, last line, and I can just highlight all of this and then command / and just comment it out very quickly. This is obviously nice, when you're just writing text. Most of the time I use this specifically when I have pieces of code that I just don't want to run right now. Either they take too long and I want to test something else, or they're crashing and I just want to see if the things around it are working. Then, in this cases, you can do that to quickly comment out a piece of code. And generally when you're writing, you can do a similar thing where you're, this is my comment, but it's getting too long, so I'm splitting it up. So, different ways, but generally everything after this hashtag symbol is not going to be looked at. So you can also start it here, a formatted string, and everything up to here is going to be fine, and then everything starting from here is just going to be ignored, even if we have, for example, like another hashtag symbol here. It's going to be completely ignored. So we can run this, we can see everything still runs fine. Now there's two conventions that I just have been using but also want to point out to you. For comments, we always want to leave a space after the hashtag, like we have here everywhere. And if you have a comment on the same line as a piece of code, you're going to want to add 2 spaces to separate it like this. You don't want to do something like this or like this. It just makes it harder to read. So general styling guidelines are 2 comments after the code, 2 spaces after the code finishes, then your hashtag, and then another space, and then you can start your writing. And then obviously sometimes, when you're working and you want to leave something, a note to yourself about something to do, some code editors, and PyCharm is one of them, will actually do some sort of highlighting for you. So for example, if I write in here, to do, I need to do these things, then a keyword like that can actually be recognized and make it easier to see. Now this doesn't happen in every code editor, but some of them, PyCharm included obviously, have these extra things. So, this is specific to your code editor and are things that you can look up, but, generally comments can be a very, very helpful thing, either to describe what's going on or also just leave notes for yourself as you're going through a project to make sure that you don't miss things and that you come back to it and that you do a double take or that you have tests or, whatever it may be. But just also be careful with comments. You don't want to have your code littered with comments. You don't want to have old code that's commented out because then people are scared to delete it because maybe you still need it and it was just commented out for a little while. So just be very, very careful with comments and make sure that comments are really only there where they're absolutely necessary, and otherwise the code should be able to explain itself. And don't, go and edit out old code and just leave it commented out. If you are done with it, make sure to delete it so that it's not cluttering everything up. So now that we've seen different ways that we can use variables and the data structures that are also available to us in Python, let's actually take a look at how we can control the flow of a program. And the first thing that we're going to look at is going to be if statements. Now these are extremely useful because essentially every time you're checking for certain conditions, this is going to allow you to do that. So we're going to start off with a test variable, and in here we're going to have the value, we'll just have it be a for now. And now what we want to do is we want to write a very simple program that prints out, yes, we have a, when our test variable here is a, and otherwise it just won't do anything. So let's take a look at how we can do that. So in Python we have this if keyword, which, as you probably already can guess kind of just from English, allows us to start this definition. So we can check here, we can say if test var, now we're going to have equals equals a. And let me just finish writing this, and then let's take a look at this and just understand what's going on. We're going to print out, yes, we have a. Okay, so what's going on here? So we've declared our test variable here as the name test var, and we've done this by using the assignment operator, which is this single equal sign here. Now when we want to check if it's equal to a specific value, we have to use this double equal sign, and this allows us to check for equality, and this will give us back a Boolean value. So for example, in this case, with the comparison, we're going to check test var equals equals a, and this is either going to return true or false, one of those two. And the if condition is triggered if this condition here is true. So let's go ahead and run this and just see this in action. So we're going to see, okay, the value here is a, and we're going to say, yes, we have a, and if we change this value instead to b, then we're not going to print out anything. Now remember, this is triggered when the condition here is true. So if we just write if true, this is always going to trigger, because essentially all that it's looking for is this full condition, whatever it may be, and we'll see in a second how we can expand upon this. If all of this expands or evaluates to true, then we're going to print it. And if we have false, then it's never going to enter this condition, as we can see here. So let's just bring this back to what it was before. And then as a quick side note, let's just quickly add in here quotation marks. So let's say we want to have quotation double quotes like this, but we're already using double quotes. We can use the backslash, which acts as an escape character for us. So we can see here, update this to a. So you can see here we can bring in these quotation marks like this, because now we don't want them to act as a way to end the string. Alternatively, we could also use single quotation marks on the outside, and then we no longer need this escape character because we're already within a string. So either of these will work. As a quick side note, we can either use the backslash, which will actually be an escape character for us, or we can use just the single quotation marks on the outside. Okay, so anyway, coming back to our example here. So now let's make this a little bit more practical, and we're again going to have the name, and let's just keep this with Ben, and then we're going to have an age here, and let's have this be, we'll have this be 35 this time. And now let's change this condition up a little bit, and we can say here, if the age is less than 35, then we want to print out here the name is less than 35 years old. So if we run this, in this case it's not going to trigger because our condition here is not true, right? 35 is in fact not less than 35. But if we do less than or equals to, then we can say here is at most 35 years old, since now we're not doing less than, but less than or equal to. And in this case, again, we'll evaluate to true because our condition here is being met. Now, obviously, there are times when a single check is not enough. And what we can do is we can have several checks. So let's say if, age here is less than or equal to 35, and maybe we'll have the, well, let's use the country this time, and we'll just have this be, the USA like this. So we can have a second if statement here. We can say if country is equal to USA, we can say Ben is at most 35 years old and lives in the USA, like this. So now we have nested conditional statements here, which can be useful at times, but other times, we may not want this, and really we just want to check both of these things. And we can do that by combining them with an and statement. So we can say, if age is less than or equal to 35, and the country is equal to USA, if we fulfill both of these conditions, then we can run this and we can again see we get the same result. Now, if either one of these is not correct, for example, Ben turns 36, this will no longer be true because our age is no longer less than 35, and so this whole thing will evaluate to false because we need both of these to be true, and so we're no longer going to print this out. Now, another option for us is instead of having an and, we can use an or here. So we can say, if the age is less than or equal to 35 or the country is the USA, then we should probably change our output statement because now we're changing what we're looking for. So the name is at most 35 years old, or they live in the USA. And in this case, it's going to trigger again, although the age is 36, which is greater than 35, the country still matches, and so this whole condition evaluates to true because it's this one or this one. We only need one of them to be true, and one of them is true, and so we get the whole thing filled. But if both of them are false, like in this case, the strings don't match, then we're again not going to enter in here. Now, there's even more stuff that we can do. So we've seen the and the ors, which are pretty useful, but there's even more here, and we can actually chain these together using parentheses. So, for example, let's chain some operations together. So we're going to say if the age is less than or equal to 35 and the age is greater than or equal to 18, so we're looking for this whole condition here, or the country is the USA. Let's change this or to another and statement. Then, and let's bring this down. So in this case, our parentheses are kind of unnecessary, but let's just go with it anyway. So the parentheses help us define the order of operations. So in essence, this is going to be evaluated first. In this case, it's going to return true because the age is less than or equal to 35 and it's greater than 18. So now we have true here. Oops. And now we're also checking here, and this whole thing is going to be true, and this whole thing is going to be true. So again, we're going to, did I make a, yeah, messed up the country. Let's do that one more time. So there we go. Now we should probably change this text again, but I don't want to keep updating this every single time. Now, a useful place where we can use these parentheses is if we have two statements like this, we can say, or country is equal to the USA, or country is equal to US. So something like this, we can say here is between 18 to 35 years old, and they live in the US. So in this case, we can see, or they live in the US. So in this case, it's going to evaluate to true because both of these conditions are true. But if I change one of these, this would still be true. So let's just make this be false. So this one here is false because the country is neither USA nor US, it's USAA. But this one is still true. And so we have this whole or condition, which is false or, which is true or false. And so we can nicely kind of chain these things together. Now there are some more shorthands that we can do for this. So one thing that we can do here is shorten this and basically make the comparison happen on both sides, like this. And let's just make sure that works. All right. And now, essentially what we're doing here is we're checking if country is within a specific list of values that we want to check. So rather than having this or, and then if we want to have 5 values here, we do or, we can make this a lot simpler, and we can use something called in. So we're going to check if country is in one of these values, then it's going to evaluate to true. So we're just checking, in this case we still have the age thing, but if we up the age and make the country true again, we can see here, if the value in country is in any of these values within our list here, then it's going to evaluate to true. So we don't need to match all of them, but this really just lets us choose from any of the values within here. Now, another common operation that you'll likely also use, but we haven't seen yet, is going to be the not equals to. So let's just add that in too, and we'll say and name not equal to Ben. So in this case, we're going to evaluate to false because essentially our whole expression here is going to be false since the name is in fact Ben and we have an and statement beforehand. So if we run this, we can see nothing gets printed out, but if we change our name from Ben to Mel, run this, then everything is going to evaluate again. And yeah, essentially kind of the comparison statements that you'll logically think of when you're considering what conditions should trigger, these are generally the ones that are going to be available to us in Python. Now obviously the way that comparisons work differ based on the variables. So if we're looking for equality or not equality between strings, then that obviously makes sense. But for strings, something like greater than or equal to is not necessarily properly defined. So you don't want to use these things that may of course otherwise work on numbers like floats and integers. And then the nice thing is we again also, and a lot of programming languages actually have this ability to check for if an element is contained within, for example, a list. But we could also, have a dictionary here. If it's in one of the dictionary keys, is going to be the default. So if we change this instead, just quickly to a dictionary, and we provide values for each of these, just something random here to have it. In this case, we're still going to be okay because our value is in one of the keys of the dictionary. That's going to be kind of the default thing that is being looked at. Or we could also use a tuple, just kind of going through the other data structures that we've seen so far. And this is essentially going to be treated, should be a parentheses here, not a curly bracket. This is going to be essentially treated just like a list. So yeah, that's it for if statements, and in the next lesson we're going to continue on and we're going to look at also else and elif statements, because sometimes if one condition doesn't hold but something else does hold, then we want to be able to, act upon that and essentially have a little bit more complicated and well-defined flow within our programs. So now that we've seen if statements, let's take a look at the elif and else statements, which essentially help us round out this picture and gain more complicated and more intricate control flows in our programs. So you may have also already been wondering this, but if we have a single condition, all right, well, something, it could hold true, but it could also not be, and if it's not, we may want to do something else. So for example, let's just go back to the basics where we had just age being less than or equal to 35, and here we'll say is at most 35 years old. There we go. So in this case, what happens if the person is older than 35? Because if we just put a print statement here and said name is over 35, and if we run this, for example, for 34, do here Python 3.9 main.py, so we can see, obviously this is not giving us what we want, because we trigger this if statement because our age is less than 35, but now we basically continue on outside of the if statement again, and now we trigger this. So this is not what we want. So what we want is we want to say, all right, well, if this condition does not hold, then we want to do something else. And that we can do with an else statement. Now, an important thing to know about Python, just kind of as a side note, is we're always using indentation to kind of define blocks of code that are within a set. So you can see here within our if statement, it starts on the same line as the previous code. And when we're in the if statement, we're going to have an indentation here. So either this is going to be a tab or 4 spaces. Really, you can use whichever you prefer. Personally, I find the tab a lot easier to use, but just make sure that you're consistent with whatever you're using. So we can see here, we go into the if statement, and we are indented here, and we can print this out. Now, everything that, as soon as we finish this indentation here, we basically exit out of this if statement, and there's no way for us to get back into it. So then we reach the next line, and that's going to be the else statement. And this triggers the condition if all of the previous cases, and we'll see how we can expand upon that in a second, if all the previous ones are false, then we will go into this condition. So let's just see this in action. If we run this, we can see here, okay, we trigger the if statement here, and now let's go to 36. And we run this, we can see here Mel is over 35 because didn't go into here, and so now we hit this else statement. Now it's important to be aware of this indentation thing, and there's also just something if we have if statements and an else statement, they need to be continuous. So we can't have a piece of code between these. For example, if we put in just a random print statement saying we're currently here, whoops, this is not going to work because now we have something that's breaking these chain of if and else statements. So we can already see like my code editor highlights this in red, and it's basically indicating already to me that there's an error. So we can see here it says that the statement expected that it's expecting essentially an if statement beforehand because we have an else here. So if we run this, we can see here we're just getting an error, and that's because we can't have any code in between here as we're doing our if and else statements. And as long as things are indented, we can print here another line and a third line. Everything that's within this indent is going to be part of this if statement, which if we put the age back to 34, we can see here. And as soon as we exit this, again, we're done with that case. So we have the if, we have the else. Obviously, there are probably very many conditions where we would have more than two choices. So let's have some barriers here and say, okay, we want the age to be either, we want to do a check for 20, we want to do a check for 40, and maybe 60. So we can say elif age is less than or equal to 40, and then we're going to put some code here in a second. I'm going to use the pass keyword for now, and I'll talk about the elif in a second, as well as the pass again in a second, and then we're going to do another elif age is less than or equal to 60, and we're going to put another pass here. So first of all, this elif is short for else if, and essentially what it means is if this statement did not trigger, then we're going to check with this statement. So if age is less than or equal to 20 is false, then we're going to check else if. So if this is false, then otherwise, if this is true, then let's execute this. So really what this statement is doing, because we're checking for less than or equal to 20, this is going to check for basically greater than 20, but less than or equal to 40, because this thing can only be triggered if the previous one is false. We'll see an example about that in a second. And then we have the same thing here. So the elif essentially allows us to chain these conditionals together and check, okay, we're going to do this check, and then we're going to do another check, and then we're going to do another check. And if the previous ones are false using the elif, then we can go into here. The pass statement, it essentially allows us to write pieces of code and just have placeholders there without them having any function. And this is kind of, if you're building out a program and you just kind of want to build out a skeleton first, sometimes you just want to put things there. Especially this can be true for functions, which we'll see later. And then you can have a pass statement, and essentially it just allows your code to run without it actually doing anything in that case. So we can see here, if I just make this go to 36, which would be in this bucket here, nothing's going to happen because there's nothing in here, but the code is also not failing. If I left this empty, then our code would fail because we need to have something within here. And so the pass statement kind of allows us to just have this placeholder. So anyway, quick side note there, but you'll probably see and maybe use this a lot. You'll at least find it useful to kind of, as you're building things up, just continuing with your train of thought without getting lost in the details. So let's just print here. We'll say here, name is at most 40, or here I'll just say, name is between 20 and 40, and here we'll say print name is between 40 and 60. Here we'll say it's over 60. So let's take a look at some of the different conditions that we can get with our values here and how that's going to, affect what we're seeing here. So we're running this. In this case, we have 36. Okay, so 36 is going to trigger because this one fails. And so now we have an else if statement here. And because the previous one is false, this one will trigger. So we're going to check this one. Okay, it's true. The age is less than or equal to 40. And we can see we have the result printed out here. Now we can go to the next one. Well, yeah, the age is less than or equal to 60, but the previous one is already false. So we're not going to trigger any more else if or else statements because we already have a true value in our chain of conditionals here, essentially. So the elif and the else statements only trigger if all of the predecessors here are false. However, something that we can actually also do is we don't need to start with an if and then have elif, elif, elif. We can actually have several ifs in series. So if we do something like this and we put in here 18, and then here we have to change this because you'll see in a second is at most 40. And let me just move this over here. If we run this, we can see here, okay, so 18 is less than or equal to 20. So we're going into this block. We can see this printed out here. Now we're going to the second if statement, well, in this case, there's no elif, so it doesn't matter if the previous one is true or false. This one is just still going to look at this raw conditional. And so here, the age is again less than or equal to 40, and so we're also going to get this printed out. But now we have the elif and the else statements, and they kind of look to the ones that happened previously. And since this one was triggered as true, these ones are no longer going to be considered. So we can see there's a lot of cool stuff that we can do with the if, the elif, and the else. And of course, we can also nest them together so we can have more if statements in here. And then, if we want to, we can have more if statements in here. And then we can have another elif statement here, and so on. So we can also put them, one within the other. And the way that we're kind of defining what is within what, so what the context is within each, is all done through indentation. So yeah, just be aware of that, because this can be really useful to just do a lot of checks, especially when you have a lot of edge cases you need to consider, or just a more complicated program flow. So we've kind of used the default comparisons a lot with the less than or equal to, or just checking for equality, not equals, greater than, that sort of thing. But there are actually some other cool things that we can do too. So let's just take this away for a second here. And let's just use a Boolean value. So we're going to say is over 18. And we'll initiate this one to false, but we can actually do something like this to age is greater than 18. And this condition is going to evaluate to false because this is not greater than 18. So we can see is over 18. We can just print out the value here. So we can actually initialize a variable too using this expression. This would be the same in this case as just putting false here. But we can see this just gives us the false value as a return, and the value stored in here is then false. All right. So we've seen before if is equal to or is less than 20 or something like that. But in Python, we don't usually do something like, if we have a Boolean variable, we don't say if is over 18, for example, is equal to true, then print is over 18. So this works, but we generally don't do this. Instead, what we do is we write is. So if is over 18 is true, this is basically checking if this is true, as you can so easily read, then this is going to check, or this is going to evaluate to true. And similarly, we can check if something is false. If is over 18 is false, then we can say is under 18. So we can see here in this case, this is triggered because this condition is false. So false is false, which is true, because false is false. So that gives us true. And so because it's true, we come into here. Now what we can also do though is we have this whole true expression here. But actually what we can do is also we can just use the variable itself. So this is a Boolean variable. And so essentially whatever this value is right here is either true or false. So we can just say if is over 18. So if this is true, this is going to trigger. In this case, it didn't trigger, but let me just change the word. So in this case, it didn't trigger. We're just still printing out what we had before. And if I change the age to 19 here, for example, then this variable is going to be true, which we'll also see in our output. And now this is going to trigger because is over 18 is true. So we can see that this is being evaluated here. We've seen none values before too, and none values are done in a similar way with the is statements. So we can see, just have we'll call this random none. And this is just going to take on the none value. And if we want to check if something is none, if this variable is none, that's how we're going to do it. And then we can put in here, yep, we have a none. So we can see if we run this, this variable is none, this condition is true, and so we come into here. If this is anything else but none, for example, the string none, which is just string, then this no longer evaluates to true. This can be 0, essentially anything else. So this is also how you can go about checking for none values. Now another cool thing that we can do is a not keyword, which we can use together with the is, or also just with Boolean expressions. So if you want to say, if this random, we don't even want to call it random none, just call this random value. If random value is not none, then we can say here, yep, we're not none. So we can see, again, we're triggering this condition. So we have some really cool keywords in Python that you can see that just make it super, super easy to read, because essentially we're just kind of typing out English here. So you can use the not, but you can actually also, the not is essentially something that negates. So it kind of does the opposite, which you probably already guessed. But let's see this with the is over 18 again here. So over 18. So if this is true, which we've seen previously, then this will trigger 19 is over 18, so this evaluates to true. And if we put a not in front of here, this basically negates this, and you can see we no longer go into it. So if we move this to 17, it's going to evaluate to true, or maybe we want to change this to at most 18, because if we have 18 here, it's still going to evaluate to false. So we can see we can use the not to just, make things a little bit easier for us again. Finally, I also want to show you how you can use these very shorthand statements for other types of data structures. So we've seen it for the Boolean where we say is over 18, like this. But what happens if we use a non-Boolean value? So if we look, for example, if random value, what's going to happen here? In this case, we're going to evaluate to false because this here is an integer, or it's just a numerical value, and any value in this case that is not 0 will evaluate to true, or is considered truthy, is essentially how we would say it in Python. So anything that is not 0 here is considered truthy. So we can see if I put in here anything except for 0, we're going to go into this statement here. You can try this out yourself, of course. Play around with it if you want to, but if we have a 0 here, then this is considered now falsy. This is kind of the one default false value for this set of data types. So numerical data types, if you have a 0 there, that is considered falsy. So you can see this becomes a little bit of a shorthand if you want to say something like, if something is not equal to 0, then essentially the only case this doesn't trigger is when this is 0, and anything else will trigger it. And so in that case we can just shorthanded, because the default falsy value for numerical data types is 0. So we can see here. Now for more complicated data types, that basically happens when the length is 0. So for example, if we have a list here, and we can say, if we have a list here, this is going to evaluate to false because the length is 0. So we can see we're not going in here. But as soon as we add any element into this list, we're going to go in here. And obviously you can play around with that too. Similarly, for a tuple, as soon as we have a single element in here, it's going to evaluate to true. And if we just have an empty one, that's going to be the only time it's considered falsy. And also similarly with the dictionary, if the length is 0, then it's considered as false. And otherwise, as soon as we have anything in here, then it is again considered true. So this is just a nice shorthand to be aware of, and you may also see it sometimes that, if you're basically looking for, do we have anything, then you can use these shorthands, and it just helps you save a little bit of space, and it can help you with your coding, but also if you're reading code, just, understanding that this is how it works can, make it a little bit easier to understand the code without having to go and look it up. All right, so we've just learned a very useful, or our first part of actually controlling the flow in a program, which is through if, else, and elif statements. Now we're going to learn another very useful and very common thing that, is generally used when writing programs, which is going to be loops. And we're going to start with
for loops. So let's say that we want to do something a certain number of times. So rather than having to write it out every single time, for example, let's just keep it easy and, print out hello. And let's go ahead and run this. You can see here we can print out hello, okay? Let's say that we want to do that just for fun for maybe 5 times. Right now, the only way we know how to do that is basically just copy pasting this until we have 5 times. And obviously that's not really nice. And generally this doesn't, expand well or generalize well, because there could be times, let's say you get a list of users and you want to update every single user, or you want to put every single user into, say, a database. You want to be able to take and go over every single one of those users, and you don't even know how many users you have. And so trying to be able to, copy paste that beforehand and have as many statements as you need is just not going to work. So that's kind of where loops come in, because they allow us to repeat the same thing over and over and over again. So let's take a look at that. So to start a for loop, we're going to start with the keyword for, and then we're going to have some variable name here. Now this variable doesn't need to be declared beforehand, but it can be. So, if we had, let's just take a very simple variable I, and if we set this to, say, 5, we can still reuse I in here. Now I is just kind of a common default variable that you may use, although we'll talk about in a second, and also just think about generally what we've learned about naming your variables. This is obviously not a very great variable name, but we're just going to use it for now because it's kind of one of the default ones that you use just in the beginning when learning. So the next part of the for loop has an in. We've seen this before when we were checking for if statements, for example, if something is contained within a list. So we're doing something similar here. We're going to basically say I in, and then some sort of expression here that has multiple values that we can loop over. Now a very common thing you'll see is this range method. And now here we can define essentially the start, the stop, as well as the step that we want to take. So for example, let's say we want to start at 0. We want to, this is supposed to be the stop, not the step. We want to stop at 10, and we want to go in increments of 1. So what this means is we're going to go starting at the number 0, and the range here, this is important to know, is up to but not including. So we're going to go up to but not including the number 10. So we're going to go from 0 to 9 in steps of 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's just go ahead and print this out. And every single time where we go through this loop, our I takes on a new value. And sorry, I messed up the syntax here. We need to have a colon at the very end of this too. So we have for variable in object to iterate over colon, and then just like we had for the if and else statements and the like, we have our indentation here to define what is essentially part of this loop. And then if we want, we can also just print I again outside here, just so that we can see that all of the things that are indented are part of the loop, and once we stop the indentation like we previously learned, we are now outside of this block of code. And I actually need to get rid of these because it doesn't like me defining it like this, but this is kind of more for example purposes. So there we go. Let me put this at the back here. So we have start, stop, and step, just so that you can remember the order. So we can see here, we're iterating between 0 up to, but not including 10 in steps of 1. And then we have this final print statement that prints the number 9 out again, which is the last value I took on. And you can see we had it defined beforehand, but it doesn't really do anything. It was just overwritten. All right, so there's actually a way that we can simplify this. So the range kind of has different ways that you can input it. So if we only have 2 inputs here, like this, it's going to assume a default step of 1. So we can see we're actually going to get the exact same result because it's going to assume the first one is start, the second one, or not assume, it's going to interpret the first one as start, the second one as stop, and then it's just going to take a step of 1. Similarly, it also has a default start, which is 0. So if you just want to say do something 10 times, or you want to, go up to but not including this number, then you can actually just use the range and just put the number there without having to define the start or the step, because most of the time, the most common way that you're going to do this is starting at 0, going up to whatever number you want to go to, and taking a step of 1. So we can see we get the same result here, and so this is just a very useful shorthand that we have for it, and in this way, these are essentially optional, with the priority being if we have 2, it's going to be start and stop, and if we have 3, it's going to be start, stop, and step. So if you'd like, you can play around with that a little bit and, just see what you get when we have all these different things. You can actually also use negative numbers here. So we can go from -1 up to 10. It's going to work fine. You can see here we start from -1. We can go from 10 down to 0 in steps of -1. Now remember, we're always going up to but not including this one, so we can see we're counting down here. So there's a lot of cool things that we can do here. The only thing that we can't do here is use non-integer numbers. It doesn't like that. So you can basically kind of use positive and negative numbers as you like here, as long as it makes sense. But just don't use non-integer numbers. Obviously, if you have something like this, then this loop isn't going to trigger because it doesn't make any sense. You can't go from 1 to 10 by counting down from -1. So if there's nothing to trigger, then we're just not going to go in here. So just be aware of that. And you can see in this case, actually, the variable I was never overwritten because this result here is empty. And so our value I never actually takes on a result here. And so with that, our I never gets overwritten previously. So a very common way where you would use this is, let's say we have a list. I'm just going to call this my list, and inside I'm going to store A, B, C, D, and E. So a very common thing to do is just loop over, let's say we have here 5 elements, so I'm going to loop over this 5 times, and maybe now I can be more specific and I can say, okay, I is actually my index, like this. So we can say for index in range 5, so it's going to take on the values 0 to 4, and that's exactly going to be our indices here, 0, 1, 2, 3, and 4. And then we can just store our value temporarily by looking at my list, taking out the element that corresponds to our index, and then if we want, we can print out our index as well as the value. And I'm just going to take this away now. And so if we run this one more time, we can see here 0A, 1B, 2C, 3D, 4E. So we're going over, and every single time, as we know, our element here is taking on the values from this range, but then we're also actually accessing the values of the list. Now we can take this one step further, because usually this is not the best approach if you want to take indices over a list, because our list here may be of arbitrary size. And if we write a program, we may not know that beforehand, because, for example, like I mentioned previously, a program could be some sort of program where you can upload students, and then that program will format it and put it into a database. And you could upload 1 student, you could upload 500, you could upload 6,732, whatever. We don't know that beforehand. So one way that we can make that dynamic is, rather than going up to just a fixed number, we can actually go up to the length of our list. And so now, for example, if we add in a new element into our list here, run that, we can see here this automatically adopts based on the length of our input list here. Now this is already pretty useful in terms of getting indices, but really if all that we're interested in is getting the values, and we're just using the index as a proxy to get out our values, then we can actually change this a little bit, because we can't just, and the example here of the range is just, it essentially creates this distribution for us to loop over. But basically, there are a lot of different things that we can iterate over. Lists are one of them, tuples another. We can actually also iterate over dictionaries, which will give us the keys within. So if we want, I'm just going to take this out and also remove these comments now because they no longer make sense. We can actually just loop over our list, and every single step we take is going to be an element within our list. So we can see here, this way we can very easily just loop over our list. And if we have a second list, let's call this and something like this, something just, random, then let's say right now what we want to do is for every single element in our first list, we want to the back of it, add on these. So first we want to do A, D, E, F, and then we want to do A, F, G, H, whatever, just something random for now. Again, just like we've seen with the if and else statements and the like, we can continue nesting this. We can put in another for loop here, and then we can put in another inside, etc. So we can have our second value be the ones from our second list, and then we can create, let's say, our total value, which is our value plus our second value. I have a typo here. And then we can print out our total value. And maybe let's just in here also print out, well, this is going to get pretty long, but let's print out our second value also. And then let's print out our value out here, just to see what happens. And I'm going to take out one of these elements because I don't want our output to be too long. So what we can see what happens is we go into our for loop. We take on the value here, A. Should probably take this way too. Now we go and we reach the next step. And so now we're in this loop. So we take on D, E, F and F, G, H. And then with each of these, we basically put it together so we can see here. And then we go to B, then we do the same thing. So what you can see, for every time, for every element here, we now enter a second loop, and we basically loop over this inside thing. So we go A, and then D, E, F, F, G, H, B, D, E, F, F, G, H. And so we can see the innermost loops are the ones that are going to be taking priority and essentially repeating themselves for every value in the outside loop, if you do build something up like this. However, be aware that when you're doing this, the time it takes for your program to finish is obviously going to increase, because essentially what we have now, and this is, we're not going to get too much into this, but this is something pretty important to be aware of, is we have the computation time is going to take whatever the length of this list is multiplied by the length of this list. So essentially we have some sort of quadratic computation time, which is not great because as each of these expand, our time for the program to run increases quadratically. So that's, just be aware of that. As you're nesting these things, then our computation time is going to be going up, and it's going to be doing so quadratically, which as our elements get big, that is a very bad thing. So just something to be aware of there. All right, some other small tips I wanted to share with you, something that you'll see occasionally or may want to use occasionally, but probably not too often is, and let me just quickly take this away here. Sometimes you can just use a dummy placeholder value, like underscore, or underscore is the dummy placeholder value you would use in this case. And usually you would use it because that indicates that this is basically going to be discarded. So let's say you want to iterate over these, whatever, in this case we're iterating over the list, but whatever, you're in a for loop, but you don't actually want to use the variable. The most common way could be like, you just want to do something 5 times. You don't really care about the value. And you could put it as an underscore here, and let's just say we want to print out hello 5 times. We don't need the I because it's not going to do anything for us, right? There's no difference. If we use this here, we're not using it anywhere. And so in these cases, it would be good to put an underscore here, which indicates to you and everyone else reading the program that this variable
is not being used anywhere, and you're essentially just in it for the loop. So you can see here, we're printing out hello 5 times. The value here is just discarded. Now, another useful thing that I actually use pretty often, that I find very useful, is, let's say, I'm going to change these up a little bit. Let's have here names. So this is going to be Ben, Mel, and I don't know, Greg. And let's have here the ages, and let's have that be 21, and we'll have 24, and here let's say 50. So let's say that we want to basically take the name and the age of, we know that these are connected. So Ben is 21, Mel is 24, Greg is 50. So the kind of naive way of doing this is, well, we know, okay, each of these is gonna, these are gonna be the same length because each one has a corresponding element in the other one. So we can loop over the range of the length of one of these lists, and then we can basically have the name equals names I, and the age equals ages I, and then we can print out, for example, the name and the age. Now this will work, and it's probably better if you call this index, just to make it a little bit more clear. But there's actually something really cool that we can do in Python, which is called zip. And here we can then put the names and the ages, and this is going to combine these two into an iterable in and of itself. And now we can iterate with 2 variables. So we can use name and age like this. And essentially, this allows us to, in the for loop case, loop over the names and loop over the ages at the same time. There's a lot more usages for this, and I don't want to get into all the usages because it's a very, very cool method. But because we're talking about for loops, I think this is a very important thing to mention because it can really help you save a lot of time as you're writing, because this is one of those things that's very, very common to write. So we see if we run this, we can just take on both values here, and if we had a third list, let's say zip code, it's going to be 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6, whatever, even if they're supposed to be 5 letters. And then here we can take on our 5 integers. We say here's zip code, and oops, it's supposed to be an S at the end, zip code. There we go. So we can just extend this, and this personally I find extremely useful, and I use it pretty often because sometimes you will have these scenarios where you have 2 maybe lists in this case, or tuples, or maybe a list and tuple, or whatever it may be, and you know that every element has an associated one in the same place in another list. So this way we can very easily, very quickly, in very little amount of code, loop over all of it without having to access the element from the list, and then, those sorts of things. All right, we just had our first look at loops with for loops. Now I want to show you another type of loop that we can use, which are called while loops. So as we've seen with for loops, we basically do for something in something. A while loop essentially means while a certain condition is true. So let's create some sort of basic variable on the outside. We'll say count, set that to 0. Now we can say while count is less than 10. All right, so while our count value here is less than 10, let's do the following. Let's just print out our count. Now let's increment our count by 1. So this is pretty important because if we don't do this, we're going to be stuck in an infinite loop. We'll talk about that in a second though. And let's go ahead and just run this. So what we see is essentially what you would expect. We start at 0 and we just continue looping. Every time we go through this, we take on a different value. And at the end here, when our number is 9, then count is incremented by 1, which makes it 10. And 10 is not less than 10. 10 is equal to 10. And so our loop stops. Of course, we can also use all the conditions that we used here. So we can also use the less than equal to, and this will make it go up to and including 10. But yeah, we won't go into the conditionals so much here because we've already taken a
pretty good look at those. So while loops are pretty useful because sometimes you just want to do something a repeated number of times until you get a desired result. And so in those cases, a for loop may not necessarily be the best thing because you're iterating over something that is essentially defined, whereas a while loop essentially allows you to, try a certain number of times or do things up to until a certain condition is fulfilled, whatever that condition may be. Now, while loops can obviously be a little bit dangerous sometimes. Like I already hinted at before previously, we can get stuck in an infinite loop. So if I take this away and just run this, then we're going to get stuck here. So I'm going to use Control C, which is going to interrupt this running on a program here. For Mac, if Control C doesn't work, you can also try Command C, but I'm pretty sure it should be Control C. I use an external keyboard, so my keyboard layout is a little bit different, but yeah, that's essentially how you're going to get that to stop. All right, so we can get stuck in an infinite loop here, which generally is not good, but sometimes actually you may just use an infinite loop. So something that you could do is just have like while true, and this again will just bring you into an infinite loop because there's nothing that can change. True is always going to be true. So if I run this again, we're going to be stuck. Control C, and that's going to kill our program here. But that's okay because there are also other ways that we can define the flow of our loops. And we'll take a look at these two statements now. So I'm going to, well actually let's leave it as while true here. And what I'm going to do is essentially the first thing I'm going to do is I'm going to increment count by 1 here. And then let's print out our count. But what I also want to do is every time we hit an even number, I want to skip it basically. So I want to have something here where I only print out the odd numbers. So what I can do is I'm going to use an if statement. If count. Now to check for something is even or odd, we can use the modulus operation. So looking at the remainder. If the remainder of count divided by something, so the value here that we want is 2 because even and odd are alternating, right? One even, one odd, even odd, even odd, even odd. So for all even numbers, our remainder of dividing by 2 is going to be 0. And here I can leave a comment checking if even. So if our number is even, because we've incremented it now previously, I want to skip. I only want to print out the odd numbers. So how do I skip? Well, there's a cool keyword that we can use here called continue, which basically means just continue on to the next stage of the loop. If whatever we're doing here, whatever the loop is, if we hit a continue, then we're going to restart the loop at the next step. In this case, it doesn't really do much because the next step, there are no values that change. There's nothing new that we take on, but we can actually also use this continue statement and also the other statement that we'll see in a second, the break statement, in for loops. And in those cases, you will be taking on new values. In these cases, we won't. So let's take a look at this and run this. Okay, very quickly quit this. So we can see here, we're always printing out the odd numbers. A lot of output spam here, but you can see here, every one of these numbers is odd. So every even number we've skipped. Cool. So let's not get stuck in an infinite loop, but let's keep this while true here. So what I want to do is I want to print all the odd numbers up to 20. So what I want to do is if our count is at least 20, so usually you can check for equality here. Generally, I like to do greater than or equals to because it provides a certain amount of safety. If some sort of increment, like happens twice or you make a mistake somewhere else and maybe you don't have like a +1 but you have like a +2 here or something like that, and you start like this,
then if you have a perfect equality to 20, you may just skip over that. But essentially what you want to do is, if I'm at least 20, so if our count is greater than or equal to 20, then I want to do this condition. So yeah, generally I like to use this because you're doing the same thing essentially, but you have a little bit more safety if you made a mistake somewhere else and your program's not going to be stuck in an infinite loop. All right, so if our count is at least 20, then what I want to do is I want to stop. I want to get out of this loop. And I'm going to add a print statement at the end here, ended loop, and the very beginning here, starting loop, so just so we can see that. So to get out of a loop completely, we can use this break keyword. This will break whatever loop we're in. It's not going to break all the loops. So if we have another loop, out here, and we have a break statement here, we're only going to break out of this loop. Similarly, the continue is only going to work for this loop. So we're not going to go through all of them. It's just going to be the one that we're currently in. Just be aware of that. But yeah, taking this away again and running this, we should now get all, you see, it's already great that we did this because if we would have done the equality for 20 check, we would have just been stuck in an infinite loop. So maybe what we can do instead is change this from greater than or equal to 20 because we want to go up to 20 and not over it, greater than or equal to 19 because that's the number that we're going to hit down here, because when we actually reach 20, we're going to skip over it. So good thing we didn't put equal to 20 or else we'd be stuck in an infinite loop right now, which when we're testing is not that big of a problem. But if this application is running live somewhere, we don't notice immediately that it's stuck in an infinite loop, then it's essentially just not available anymore because it's stuck on the same thing until you realize at some point that it's not working as intended. So we can see here, we go up to 19 and bam, we now break out of the loop and the loop is ended. So yeah, continue and break, very useful keywords. And we can also use them like I mentioned before in for loops. So we can say for I in range 20, and let's just say we'll use the same thing here. If the I is even, we're going to continue. Otherwise, we're going to print out count here. In this case, we don't need to increment because we get the increment essentially for free because we're looping over, the objects produced from this range method here. But you see, we get, printing out I, not printing out count. There we go. So we kind of get the similar result. And here we're just skipping over, and you can see every time we reach this condition, we just continue on with the loop. And essentially, in this case, our loop is going to take on the next value in the step, so that'd be 0. And we can see 0 modulus 2 is 0, so we don't do anything, we skip. We take on the next value, 1. 1 modulus 2 is 1, so the remainder of dividing 1 by 2 is 1. So we don't go into this if statement, we print out the value, now we reach the end of our loop, we go to the top again, and so on. So continue and break are, in my opinion, very useful things to, help you even better structure the flow of your loops, because you may not use this very often, but at some point you will come across a problem where you're like, the easiest way for me to do this is as soon as I've hit the condition that I want to, I just don't want to do anything else, just go to the next step. Like I already have what I need to, nothing else needs to be done, just go to the next step. And so that's where continue comes in really usefully. And other times, the break statement can be very helpful where if something happens, you have some sort of end condition, you just want to stop, you want to break out of it, you're done. All right, so previously we've seen loops, and this is actually still the code from our while loop lesson, because I want to continue on because we're now going to look at functions, and functions really allow us to just reuse code and just make our programs a lot shorter, a lot more readable. So I'll show you, actually here, we're going to change this up a little bit with functions because essentially we have two things that we're repeating this year, and this year we're doing the same thing. If something is even, we want to print out the value. And really, ideally, when we're using the same pieces of code, we don't want to like have to copy paste it every time, because that's really bad. Because for one, if we have a mistake, we're copy pasting that mistake everywhere. And two, if we ever want to change the behavior, we have to go find every single place where it's used and then update that behavior, which obviously is very much less than ideal. Now, functions are very useful because they allow us to define pieces of code that we can reuse in a much shorter format. So let's create a function at the top here. The way that we can create a function is using the def keyword. So essentially we're creating definition. And our function that we want to create is print if even. We're going to have some number here, and what we want to do, and we can now take this, copy this here, but we have to change our variables that we're using. So if our number, the remainder of dividing a number by 2 is 0, print if odd, then, in this case we're doing continue. But what we do with functions instead is we actually use a return statement. And we'll take a little bit of a look more in this in a second, but essentially what the return does is you exit out of the function. So kind of like a break. And if not, then we're going to print out our number. So now what I can do is I can paste this function here. Now to call a function, we use its name, and now we have to pass the variable. Now this variable here I've called number, but number is only defined within the scope of the function here. So as soon as we leave this function block, as soon as we leave this indentation block, for example, here, number no longer exists. I'll show you that in a second too. Well, I guess we can try it out now. But it's going to break. You can already see my code editor is complaining because number doesn't exist, but we'll see it in a second too. All right, so to use a function, we have to have its name here, and now we have to pass the parameters to it. So in this case, what value should we pass as number? So in this case, we want to use our count as the number. And let's go ahead and run this, which is just going to fail because here we can see number is not defined. It's only defined within the scope of the function. So as long as we're in this function, we can use this variable here. But as soon as we're outside, we no longer have access to it. So let's go ahead and run this. And this is actually the output from our second loop. We'd see the output from our first loop is exactly what we would expect, but we were able to shorten this piece of code and, use our function call instead here. And again, if we check here, if we try to print out number after calling the function, again, we're going to encounter an error because number is not defined here. It's only defined within the scope of the function here. That's where we have access to this number variable. Now the cool thing here is, well, we're doing the exact same thing here, right? So what we want to do is we want to print if odd with I. And if we go ahead and run this, we can see, all right, cool. So we have the same piece of code, but we were able to reuse it, right? We didn't copy paste it. And now if we ever need to make changes, all that we need to do is change what is inside of this function here, and everywhere where this function is used, that behavior will be automatically updated. So not only does our code look a lot cleaner,
because we're describing what exactly is happening here with a good function name without having a bunch of code here, and we also get to reuse it. So that is going to save us a lot of time and headache down the road, and it's also going to make our code a lot easier to read, because obviously as programs get bigger, there are going to be larger pieces of code and that need to be repeated. And so when you have stuff like that, even sometimes if you don't have to reuse pieces of code, it can be really helpful to take larger things and put them into a function, give it a good function name. Function names, as we generally do in Python, also for variables, we're going to be all lowercase, and every time we have a new word, we're just going to indicate a space essentially using these underscores. So that way, if we have a complicated, larger block of code, then we can take this away logically into separate functions that do separate things. For example, prepare our data, apply transformations and set to our data, set default values in our data. Maybe those would be maybe 50, 80, 30, it doesn't matter, just more lines of code. But we can reduce that down to 3 lines of code that very clearly explain the exact step we're taking with every single thing. And so it becomes a lot easier to read because we essentially have expressive names. Inside of that, we do the operations that we want to. And if someone is interested in checking out that logic, they can just go to that function, and then they can read through the code there. And then of course the other added benefit of being able to reuse it and all that good stuff. So yeah, all right, so we've seen the basic function here. Now I'm going to take all this away because we've seen how we can use it to reuse. But I also want to take a look at that return statement that we had, as well as also the parameters that go in. So let's create a function that does add 1, and we're going to call our variable number here, but actually be careful, because just because we call this number or something, this doesn't guarantee that someone will actually pass an integer in. Now this is a pretty big problem in Python. In other programming languages, you have this thing called type safety, where essentially you define what type you want to have in here, and then before the program can even run, it will just make sure that everything that is being passed around, everything is compatible, so that text or strings can even be passed in here. We're going to talk about this a little bit more in more detail later on. We're just going to ignore this for now, and just because we're using our program, we're just going to do it correctly. But obviously, even if we write the code ourselves, if our programs get very big, sometimes we may make mistakes, or we assume something about our input data, and it's actually not like that. For example, we could assume an ID to be numerical, but maybe that ID can also contain characters, and it's actually alphanumeric or something like that. So, we can also make assumptions that just don't hold, and that can break our program. But for now, we're just going to assume that all of this is valid. So what do we want our add 1 function to do? It's going to take in some input, and it's going to essentially return this value that we have inputted here, but 1 larger. So we're going to take our number, and we're going to add 1 to it, and let's create our start number, which is going to be 1, and let's print out the response that we get from calling add 1 with our start number. So running this, as you probably have guessed, okay, our response here is 2. We call the add 1 function, we provide our start number as the input, this value here is 1, and then the return, so this is what we get out of the function, is whatever the input is plus 1. And if we call this multiple times, we're going to get the same response, because we're not updating our value here, we're just incrementing it. So now you may be wondering, okay, so what happens if I do this a different way? So let's just do it like this first. We can create new variables within a function and then return those. And again, these variables will not be accessible outside of the scope of our function here. We're going to get the same results. And we can also use our input variable. We can do the shorthand for plus equals and return the value here. And even here still, we're going to get the same response because generally in Python, we're not passing the object itself, but we're passing a copy of it. There are some very weird cases where you will actually find this not to be true. Mainly, I've encountered this when dealing with dictionaries in some way, so just be aware of this, that sometimes when you have like nested dictionaries here, for example, this assumption may actually not completely hold. So just be aware of that. But generally, when we have these basic data types, integers, strings, floats, etc., then we're going to be, you're going to be fine updating it, returning it, and we can see here it doesn't get changed. But when you have more complicated data types, then sometimes you actually find like, why is stuff changing? And it's actually, if you take nested dictionaries and you go deep into that dictionary and update values there, sometimes that value actually gets updated from the core value. So just something to be aware of. But essentially, we're copying our data here. We're creating a new value and passing it in. We're not passing a reference to the actual value. So you can see here, we're calling the same function over and over. And in this case, with the same input, we're getting the same result, which is exactly what we would expect. Now, obviously, if we want, we can update our value, right? We can do our start number equals add 1 to the start number. And then if we print out our start number, this is going to be 2. And when we call the function on it, then it's going to be 3, because now we've updated our number with the response. So we're overwriting the value in our variable here. Now, sometimes with functions, you probably don't just want to have one input parameter, but maybe you want to do something like add numbers, where we pass in 2 numbers. So we're going to have number 1, and we're going to have number 2, and what we want to do is we want to return number 1 plus number 2. So in this case, let's say our add number is going to be 4. So we're going to call our add number function. We're going to pass here this one in our first one, and number 2 is going to be 4. So we have 2 input parameters, and essentially we're going to be taking that input. So this is going to be the first input. Oops, no. This one, this here is going to be the second input, and then we're going to add these together, and we're going to get one response like this. So we can see we have 2 input parameters here, and we have 1 output. If we want more than 1 output, so let's say add, subtract numbers. So we want to, the first output is going to be the 2 numbers added, and the second output is going to be number 1 minus number 2. So now we have 2 outputs here, and if we actually just overwrite this, then we can see we're going to get a tuple returned from here. So if we want to have, or if we have more than 1 output, we can actually initialize more than 1 variable at the same time, or update more than 1 variable at the same time. So let's create 2 new variables: numbers added, numbers subtracted. And if we copy and paste this into our print function, so we can see we're printing out the first number here, which is going to be the output of our first value here, and the second number here, which is going to be the second return value. You can see our numbers added is 5, and the value of numbers subtracted is -3. Now just be aware that if you have 1 output variable here, then we can see that when there's more than 1 output, it's just going to be stored in a tuple. Now, if we have actually, like, let's say 3 outputs, now it's going to throw us an error because we're trying to overwrite more variables than are actually available to us. So we're returning 3 values, but we're only setting 2 on the left-hand side here. So now we're going to get an error here because we're returning too many values
and we're not assigning it to enough. Now, if we did this just into one variable, then all of this will get stored in a tuple, as we've previously seen. But if we actually want to assign the actual numbers, then we have numbers subtracted, and we'll have numbers multiplied. So this means, we're going to have 3 values here. Obviously, we should update our function name here too, because now we're just not add subtracting, but we're add subtracting multiplying the numbers. But yeah, just be aware of that you can have multiple of these return values, and just want to make sure that you're storing them properly. Now, sometimes you're like, okay, well, right now I'm just interested actually in the first return value. Sometimes you have that situation, you'll know it when you have it. So in those cases, you're like, okay, I don't want this to be a tuple. I don't want this. I want this variable to just have this first value here. So what you can do is actually, and we've seen this in the past with the underscore, we can do star underscore, which means, okay, we're going to assign this first value in this case, and everything else is going to be discarded. So we can see here our value takes on the number 5, and if we can do this with more than one, so we can have numbers subtracted. So we're going to assign the first 2 response variables, the remaining ones are going to be discarded. So we have 5 and -3. We could also put this in the middle, for example, numbers multiplied. And so essentially we're taking the first and the last, we're discarding the middle, we can put this at the end, and we're discarding everything except for the last one. So, you can do all sorts of combinations with this depending on your actual needs. And this way, it just becomes a little bit easier, and it saves you that one extra line of code where you're accessing the tuple, accessing a specific element in the tuple, assigning it to either a new variable or the existing variable. This way, you can more properly define, initialize, or either update the variables that you have based on the response from your functions here. All right, so we've previously looked at functions. I want to continue with functions because there are some more things that you'll likely see a lot. So yeah, let's go ahead and take more looks essentially at these input parameters here. Right now we're just defining them in order, right? We have number 1, number 2, and then we're like providing the input parameters. But something that you may want to do is more explicitly define what exactly should be the first number and what exactly should be like the second number. So one thing that we can do is, let's say, okay, let's say we have our inputs. We have the start number and the add number, and maybe we're not exactly sure how, this is going to, like, what the order is here, or we generally know what we want, and we just want to define our, input variables. So I want this one here to be number 1, this one here to be number 2. What I can do is I can assign it like this. So let's go ahead and run this. And so we can see we can actually use the variable names here and assign them like this. So that makes it a little bit easier sometimes because, in this case, obviously, okay, we have number 1 and number 2, but sometimes when you're more explicit about certain things and you have maybe a lot of input parameters, then you can define exactly which ones you want to set by just using these keywords and assigning values to those keywords. And it also gives you a little bit of safety because obviously now I know that start number is going to be number 1, and I know that this add number here is going to be number 2. And I don't need to rely on the certain order of inputs here to make sure that that stays true. I basically have this assurance now that this is the way that it is. Now there are also some cool things that we can do, specifically setting default parameters. So let's say we have our number 2 here, and if there's no input provided, I want to assign this to 1. So let's say, okay, this way we can say, okay, so we're going to provide our start number, and in case
because our number 1 here is kind of like the first one that gets assigned. So in this case, if I just run this, we can see we still get an output because our first parameter here is going to go into number 1, and this one here is not provided. And let's change this up like this. This one here is not provided, so it takes on the default value here of 1. And so we can see here in this case, for the multiplication case, we have 1 times the default value, which is 1, so we get 1 back here. But we can obviously still set this number, so either we can provide it as another argument, we can say add number here, and so then it's going to take on 4 again, or we can again, explicitly set it like this, and we can say, okay, number 2 is equal to this. Generally, you kind of want to like pick one method, or at least, and actually Python won't even allow you to do this, but something like this is not going to be allowed. So your keyword arguments, that's what they're called, always need to go first. So if you use a specific keyword to define the argument here, it essentially first you're always allowed to use the arguments without names, and it will just be taken in this specific order. But then after that, if you do want to assign it by the names of the actual arguments that we have here, we can only do that towards the end, and as soon as, or not towards the end, we can do it whenever, but as soon as we start using it, we have to continue to use it. So we can't use it first and then not use it. We can either use it towards the end, and then if we had more numbers or more input values here, we would always have to use the name and the assignment version. So this would be okay. Or, if we start at the front here, then we can just use it, in this case, for everything. So this would work, but we can't use it and then not use it later. So once we decide to start using it, whenever that may be in our parameter or argument list here, we have to continue using it. And we have a kind of similar rule for our input, for our default values here. So if I set a default value for this, this is going to be like 1 and 1. So in this case, I can actually call my function without any input parameters, and it will just take on the default values. I can also call it with just one input parameter, and that one is going to go into the first argument here, like this. I can call it with 2 input parameters, and it's going to take on the first and second. It's going to, basically this one's going to be our first argument, this one's going to be our second argument. We get the expected result. So all of this is fine and great with our input parameters, and we can even, do something like this. We can say, okay, this is going to be number 1, bam, it works. Or, well, in this case, maybe we would use this one here. This is going to be number 1, or this one's going to be number 2. Obviously, in this case, with multiplication, it's going to give us the same result. We can do all of this stuff, but we can't have the default parameters set and then later on not have them like this. So similarly, like we can't start using the keyword arguments and then later on not use them. As soon as we start allowing default parameters, we have to continue using them for every single argument that follows the one that first uses default parameters. So we can see my code editor here is already underlining this, and it's just going to complain because, well, we don't have a default argument here, but in an earlier variable, we did use it. But here, this works because, we haven't used default parameters yet, and then we can have some input arguments here, and then as soon as we start using it, then for everything after that, we have to start using it. Obviously, in this case, we're going to fail because number 1 here is not defined. So yeah, we can either, define it like this, or again, just providing it as input like that. All right, so let's take even more looks into what we can do with these input arguments. One of them first is going to be actually kind of dynamically providing the inputs. So let's say we have some dictionary that has our input values. And as long as, and we're going to have our dictionary keys match the input names here. So our key here is going to be the number 1, and the value here is going to be the value that we want for the number 1. And our key here is going to be number 2, and the value that we want here is going to be the value for number 1. Now what we can do here is we can actually use our dictionary, and we can use this thing we can use a double star. And what this does is it unpacks our dictionary, and it essentially takes our dictionary, and in this case it's going to provide as input number 1 is equal to this value, and it's going to take number 2 is equal to that value. So we're taking this whole dictionary here and we're unpacking it, and we're providing as input parameters this key is equal to this value. And so this is really cool, because sometimes it can be a lot cleaner to either set up your input values in some sort of dictionary like this, or you may already have it in some sort of structure that has this sort of format, and then you can just unpack it and pass it as input parameters like this. Now there are some other cool things that we can do. For example, if we have a list of input values instead, so let's have that be the start number and our add number here, and let's comment this out, because although we're overriding it, I don't want you to get confused with us reusing this variable. So in this case, our double star doesn't make any sense, because double star, we can unpack a dictionary and have the key be equal to the value like this. So that doesn't make any sense here, or it's we can try it, but it's not going to work. But if we use a single star, what that does is it takes this list and it essentially unpacks it, and essentially you can kind of think about it like what it does is it just removes like the square brackets around it, or if you have a tuple, it will remove the parentheses around it. But what this single star here does is it's going to just provide our input like this. So it's going to take this list and it's going to unpack it, and basically every single element here is going to be just as if we would have put that element actually in the inputs in this format. So again, this is really nice because we can use different data types here, and then with this either star for lists or tuples or other similar data structures, or for dictionaries with the double star, we can unpack it so that we can actually use the values defined here as input parameters, which again sometimes can be a lot cleaner or a lot shorter to write, because we don't have to explicitly write out all of the input here. So we can do this from the input end, but we can actually also do something like this from the argument end here. We can define star args and star keyword args, and you'll very often see this when you're actually looking at like external libraries, which we'll talk about later on in the course. But this allows us to essentially provide any extra input values that we'd like. So let's keep our number 2 here. So we're going to have number 1 and number 2, and let's provide these as input arguments again here, and we can run this. But now what we can do is I can just add in more input values, and we see our function still works, whereas if I didn't have this, it would complain because the number of input that I provide is not equal to the actual number of input arguments the function accepts. But in this case, if I print out the contents in args here, you'll see all of our input values are here. So all of the unnamed arguments that I provide are going to be stored in args. And if I take this away, then similar things can happen. Our first 2 values are going to go into number 1 and number 2, and then the remaining ones are going to go into the args, like we can see here. And for quargs, or keyword arguments, we can provide something similar, but we can provide just, test1 is equal to A, test2 is equal to B, and we can print out our keyword arguments. And we can see here that anything that is defined, any arguments that are defined with keywords will go into the
keyword arguments. Now again, the order here is important. First, we have the arguments without any names defined, and then after that, we have the keyword arguments. If we try to do something like this, again, it's not going to work because our input needs to be as soon as we start using these keyword arguments. We can't just stop using them. So if we have some other name here, we assign this to 4, that's also going to be available in our keyword arguments here, and we can access it directly like test1 is equal to keyword arguments test1. So, oops, I didn't even use it or print it out. So you can see here the value. A better way to do this though is to do the get, because that way we try to get this element from the keyword arguments mapping or the keyword arguments dictionary, and if it's not there, we're going to get a none value instead. So in this case, it exists. You can see here test1 is A, but if we don't provide it as input, then our function is not going to fail, and our value here is just going to be none. And then if we want to, we can provide some sort of like default value here, whatever this might be, like, I don't know, 12 or whatever. And so then we're taking on, if the value exists, we're taking on that value, otherwise we're taking on the value 12. And this is exceptionally useful because it allows so much flexibility and freedom in writing functions, but also using functions, because sometimes you have the base things that you need, but then you have another like tons of parameters that you can tune if you want to, and otherwise you can just use a bunch of default parameters, or sometimes you want to call a function that can take extra parameters, and you basically want to be able to like pass that on. And so let's say we had a second function, def second function, and it takes in, let's say, test1 and test2, and then some more keyword arguments, and all that this function does is it prints out test1 and test2. And let's call this function within our function here, and we can actually just pass in the keyword arguments that we're taking in. And if we run this, then we can see here, okay, so we're going in, we're printing out our args here, which is this value here, since the first two go to these two input arguments, our keyword arguments, which is everything that has keywords defined here that go into here. Then we call our second function, and in this case, all we do is pass in the keyword arguments, but obviously, we can pass in a lot more, and we're just unpacking our dictionary like we did previously. So test1 and test2 are going to be assigned to these values, and then we have extra keyword arguments that we're not going to do anything with, which is going to be this some other name here. And so we can see we're printing out test1 and test2, and then we're printing out the return value of the multiplication from our actual input here. So we can continue using these and passing these on into other functions down the line, and it just provides so much flexibility. And again, because this is a tuple, if we have like arguments here, then we can also pass in these arguments. And in this case, it's actually gonna, it's not gonna be happy with this because it tries to interpret the value that we're passing in our arguments here as the first value. So we're passing in the arguments here, which in this case is 3 because we're unpacking it. So we're going to pass 3 for test1. But then in our keyword arguments, we're also assigning test1. So if we look at the output, this is here, got multiple values for test1. So we're providing it once with this like unnamed argument, and then we're providing it again with a keyword argument, which it doesn't like. But generally, obviously, we can go about having so much flexibility in passing in our arguments and keyword arguments like this. And you may not use it in the very beginning, but as you become more comfortable and as you program more, you'll start seeing this when you go into like libraries, and you'll know, okay, this is what it means, this is how I can use it. If I want to, I can, make great use out of it. Now I know in this lesson we've gotten pretty technical and into some more depth. Don't worry if you're not like completely clear on the like arguments and keyword arguments. I know it's a lot to take in, and really we're not going to be using this very much, but I just wanted to show you because I want you to be aware of these things, because as you do more and as you get more comfortable with kind of all the basic stuff, then at some point, you're going to look into like libraries, and we'll also be using some libraries later on in the course. But, if you ever see this syntax, I don't want you to be confused about like, what does this mean? I've never seen this before. So then maybe at that point, you can either come back to this lesson, or you can even just do a quick Google search and you will have already learned about it. And maybe in that case, when you have the context, it will very quickly come back, and it will also, become much more clear in that context without you having to like learn these new concepts. So now that we've taken a pretty in-depth look at functions and all the stuff around it, I quickly want to take a little bit of time just to talk about variable scope. So if we remember, we just have create some sort of test function that takes some input x, and then it assigns y is equal to x plus 1, and we'll just assume x is a number here, and we just return y. We remember that if we, have our y, if we try to print out y, and maybe we call test function here with 1, if we try to print out y or x, both of these are defined within this function, and that's not going to work because these values are not accessible to us outside of the function. They are within this local scope of the function. So I want to show you something called global variables, where there are certain variables that you can just reuse or essentially use anywhere. So let's say we have some outside variable. Now, what I could do, let's assign this to 5, is I can actually use this variable inside of this function, because this is defined on a larger scope, and so it's available for me to use inside of this function. And we can see here, if I print out the result of test function 1, so this should give us 6 because we have x, which is the input here, is 1, and the outside variable, which is not defined within the function, but it is defined out here. And so we actually have access to it inside of the function, and then we can add to it. Now we can't overwrite this variable yet. So if we do, for example, outside variable equals 2, then try to print out outside variable, we can already see that this is not going to work. It is throwing an error because it says, well, outside variable is not defined, but you can see here when we run it, okay, that's weird. We just had access to it, but now we don't. It's because we're trying to assign the variable. And as soon as we're doing that within a function, even if we have an outside value and an outside variable that matches the same name, if we create that new variable inside of this function and we run this, we can see here our response is 3. Even though we've assigned a variable with the same name inside of this function, in this case, Python actually does it pretty smart, and it won't overwrite the outside variable, but it will create a new variable that is just local to the scope of this function. Whatever this function has, that's where the variable can be accessed in, and we can see it doesn't actually touch the outside value. However, if we do want to access and overwrite the outside variables, then we can use a keyword here called global. And then let's say we have the outside variable which we want to access. So in this case, we can use global outside variable, which means, okay, when we're referencing, we're essentially bringing in outside variable into this function, and this will now allow us to update it. So now we can see if I run it, our outside variable here has now taken on the value 2 because I've used this global keyword, which means that when I do assignment operations, I'm actually accessing and using the global variable that was defined outside of this function. So we can see here, scope is a really interesting thing, and Python actually does a pretty good job of protecting us against accidentally reusing like variable names and using an outside variable and then accidentally overwriting it. We have to be pretty explicit. If we do want to access and overwrite an outside variable, we have to first do global outside variable, and this will bring in the outside variable, the global one, into the context of our function and give us full access to it so that we can overwrite it. And then because this variable is defined outside of the scope of this function, we actually still have access to it outside of our function here. So just something to be aware of, that if we have global variables and if you want to use them, then you can use them like this. And if you're just using them essentially for reading without setting them, then you don't have to use this global keyword, it will still work. But if you do want to overwrite them for whatever specific reason you may have, then you can do that using the global keyword. Generally, it's probably not the best idea to have these like global variables assigned and then just access and overwrite them in wherever places. There are probably better structures that we can take there where we actually have them as input parameters, because then everything is a little bit more defined and we know exactly how things are getting passed around. But yeah, just a side note, and we'll probably see and use a structure like that later on as we get to the API development. But just be aware that these are different scopes, and this scope here we actually have access to in like our whole program here, but within a function, everything within this function we don't have access to outside of it. But of course, when we have global variables, we can use the global keyword, which makes them available outside. And if we try to use some sort of variable that is not defined outside, and we set outside variable 2 equal to 2, now we are actually creating a global variable inside of our function, and now we do have access to it outside. So again, scopes are a pretty important thing, and generally things within a function stay within that function unless you explicitly use these global keywords. That way, when you either create or overwrite values, that will actually affect the variable that is defined with outside of the scope of that function and will also be accessible outside of the scope. Otherwise, really the only way that we can get things out of functions is by the return that they have here and using the values that they return. So in this lesson, we're now going to take a look at creating, reading, accessing files, and all that cool stuff. Because sometimes you will be dealing with files, other times you may not, but there are some projects where essentially you're just taking a bunch of files and reading their content, you're doing stuff with them and probably saving them somewhere else, either in a different file or in a database or something. And other times you may not even be interacting with files, but it's just important to be able to know how we can read and write to files. So the first thing that we want to do is, we can see our directory structure on the left here. Actually only right now have this main.py in our folder here. So if I want to create a file, then, or if I want to read from a file, well, either I have a file in here, but actually let's create just a file first. So what I'm going to do is I'm going to save this file in some sort of variable. And I'll just call this F for now. But obviously, if you're using this a lot, you probably want to give a better variable name, but right now we're just going to have F, which is going to be the variable that stores the access to our file so that we can essentially use it. So if we want to do that, we're going to use this open keyword. And now here we can provide the, the name of our file. So let's call this test file.txt. And right now this file doesn't exist. So I want to create to it and open it in writing mode so that I can write to it. So if I use the W here, so first we have our file name, and then we have the mode that we're opening it in, which is W is going to stand for writing. So now I have this file available and I can write to it. Now generally a very good thing to do is once you've opened a file, you want to also call f.close, and then you just want to put this down just so that you don't forget to do it yesterday. This way, once you're done using your file, whenever that may be, you close your connection to the file essentially, so that way, like you open it and you close it properly and you don't have some hanging reference that is just there. Because sometimes that can lead to like problems or corruptions. So you just want to make sure that when you're done, you just want to release that, reference to the file. And that way the file reference is removed and closed properly. And then, you don't just have like this open file reference the whole time your program is running. All right. So if we just did this without anything else, and we run our main, then you can see here the file has now been created. If I double click into here, the contents are empty, but the file has been created. So if I want to write something to it, I can do f.write. And here I can do, for example, this is going to be our first line. And if I write this, and now we can see, oh, cool, contents are now in our file. So if I call f.write again, this is going to be our second line. One thing to be aware of, unlike the print statement, if we run this, we don't automatically have a new line, it just kind of gets added to it. So if we want a new line, we have to use the backslash, which is the escape character. Backslash n is going to give us a new line character. So one more time, now we can see this is going to be our first line, and this is going to be our second line. Now something that you may or may not have noticed is we're actually overwriting the contents of our file every single time. So every time we open it in a write mode, and then we're essentially going to be overwriting it. So we can see in this case, when I open it in write mode, our file is completely blank. So just be aware of that. So if you want to, instead of overwriting it every single time, you want to add stuff to it, then maybe, okay, the first time we create the file, write mode is important because it allows us to create the file if it doesn't exist. So maybe this is the first time we're using it, bam. Okay, so now our file is created and we have stuff in it. And now, obviously you wouldn't actually change this in the program, you would probably use this somewhere else. You would use the write mode when you know the file doesn't exist, or if the file does exist, you just want to overwrite the contents. But if you put the A in here, this opens it in append mode, which now allows us to add extra stuff to the end of the file. So we're appending to the end of the file without overwriting all the previous stuff. So we can say here, this is another line. And if we run this and take a look at our file, then, oh, okay, forgot to put the new line at the end of this one, but we can see it got added on. And essentially, every time we run this, you can see here we're just adding on to the back of this file. And as soon as we open it in write mode, all of that again is going to be cleared. We just have the one content in here. So we have the append mode and the write mode, both very useful in, their specific situations. And maybe something that you have is, okay, you have, you're using the write at some point, and then later on you have, I'm just going to copy this and then update it. We're going to open our file, but this time we know the file exists, and so I'm going to open it in append mode, and I'm going to say this is another line, and so here I can say this is the first line, which I know it will be because I'm opening in write mode, and it will create the file if it doesn't exist, and it will also clear it. And then in append mode, here I assume the file already exists, I'm just appending something to the end of it. So you can see here, this is our first line, line is twice here, and then we're appending to the end of it, this is another line that we have here. Now actually, if I try to open a file that doesn't exist in append mode, it's actually going to provide me a similar structure to what I have with the write, which is going to create the file for me and then just write this to it, which we can see here. So yeah, generally, important differences to know. That append, we're always going to be adding to the back of it. Both are going to allow us to create it, but with the write, we are going to be clearing it every single time. All right. Now, finally, we also have the read. So we've take this away. This is the final line, and let's run this one more time. This should no longer. Did I delete this? No, I did not. Whatever. So we're clearing our file. This is the first line we're writing to it, closing the reference, opening the file again in append mode, adding 2 more lines like we see here. All right, so we've written to it. How can we read it? We can do, again, creating a reference to our file, making sure we close it immediately so that we don't forget to do that later. Put this down a little bit. And if we want to read it, we put the R here. This is going to allow us to read the file. So one thing that we can do is we can just do f.read. This is going to read the whole file. Now, if our file is small, that's fine. If our file is big, this could be a problem because all of this is going to be stored in memory. We can actually also save this into a variable. So let's say in this case, it's going to be our file contents. If we do f.read, and our whole file contents are going to be stored now as a string in this variable. So you can see here, this is the file contents that we're printing out, which is exactly the contents within our file here. So one better thing to maybe do here, if we have the possibility of having very long files, instead we can do read line. So we can do here file line, and then we can print that out. And so we see here, this is the first line, and we actually get a double new line here. One of them comes from the print statement, and the other one comes because we have a new line character at the end here. So we have a new line that comes just from, the file contents, and then we have an extra new line which comes from the print statement. We can get rid of that if we want by having the end character and overriding that end character to instead just being nothing. And so that means at the end of our print, we're no longer by default going to have a new line, but instead we're just going to, in this case, have nothing. And just to show you what exactly this does, we can see here, when I put the K, sorry, I was just looking for it, we have like this extra character here. So we can kind of define how it ends. So if we don't want a new line, we can just set this end equal to nothing, but by default, we're just going to have this be a new line. But we don't need to set it, but just as a quick side note to be aware of that we have this extra new line because of the print statement. All right, so if we do the same thing again, we're actually not going to be starting from the top. We're going to be starting from wherever we currently are in the position of the file. So we've read the first line, which now brings our cursor essentially to the second line. So we're here. So this is what we read. This is another line. And we can see that here. So every time we call the read line, we're going through and just taking on line after line after line, and we're essentially going through. Now I'm not going to go into file navigation in too much detail because I really don't ever have to use it, but if you do ever just want to reset the position, then what you can do is you can do f.seek, and then this is actually going to be the position that you want to go at. So in this case, 0 is going to bring us back to the very beginning of the file. 1 is going to bring us one character after, and you can play around with this if you want. Just play around with these numbers, and then if we do another read line, we're again going to get our first line because we moved our file cursor again to the very beginning. Again, if you need to do this sort of file navigation, then you can look into this in a little bit more detail, but personally I've never really had to use this, so I'm not going to go into it in any more detail than this because yeah, again, like I said, in all my years I've never had to use this. So yeah, anyway, this is going to be the file reading, just something to be aware of. When you're reading lines, you're essentially kind of going through the file, but you're keeping that position. And then when you read more, you essentially continue on with that position unless you explicitly, define a new location in the file to go to. But you can think about it as a cursor that's kind of going through, and when you stop, so in this case, my cursor is here, for example, so we read the first line, and then it's here, and if we read another line, then we're going to read through all of this, and then our cursor is going to be here. So just, keep that in mind that your file handler here is actually keeping track of where you are on the file. Now, obviously, doing the read line can be useful if you want to read 1 or 2 lines, but if we want to go over the whole contents of the file, and we don't want to use the read method because that may, explode our memory usage if the file is way too big. If the file is several gigabytes big and we try to read all of it into memory, that can actually cause a really big problem because we may not have enough memory to hold the whole file contents. So again, we can use loops, and we can say for line in file read lines. So we're just going to be going over this file line by line, and it's supposed to be F, not file. You can print out the line here, and always likes to have a new line at the end of the file here, just some formatting stuff. And bam, we can see here, okay, with this, we can go over the file line by line by line using a loop, and every single time our line value is going to take on a new line in the file, and that way we can go over the whole file contents without having to read all of it into memory at the same time. We can process it line by line which very often is actually what we're doing. We're taking each line, we're processing the line, we're going on to the next line. Very often, that's a very common thing to do in programs if you're reading file contents, because it could be like a CSV file or something like that. So, very likely, not all the time, but very likely, you'll probably do the same things line by line by line. Or you'll continue to do the same things, but maybe like adding on to the data that you're saving somewhere else, or, whatever. But yeah, the read lines makes this a lot easier so that you don't have to use the dot read line method to just get a single line. We can just go over the whole file contents, and once we reach the end of the file, then we're going to break out of this loop, and then the next thing we're going to do here in this case is going to be closing the file. So yeah, one extra thing here, generally I never use this syntax because I don't want to accidentally forget closing the file. So what I use instead is something called a context manager, and we can do that with the with statement. So we can say with, and then we have this open testfile.txt in reading mode as f. So this is essentially going to give us the same as f, and then open, whatever is in here. And now we're going to be indenting this, similar to what we had for functions, if-else statements, as well as loops. And within this context here, as long as we're within this with statement, even if we go, further in, as long as we're like in here, even down here, we're going to have access to our file. And as soon as we leave this, as soon as we're out here, our file is automatically going to be closed to us. Now you can see why I prefer this, because it's a single line of code. You know exactly where you're using the file. And as soon as you stop using the file, automatically close here. You don't need to worry about it. And if I run this, it's going to give me the same results, obviously. But we can see here, if I try to, maybe we can just do like going to the beginning of the file, and then we don't need to print this out, and then trying to print out reading the file content. This is not going to work because it's automatically going to be closed for us. You can see we can't do IO operations on a closed file, can't do input-output operations on a closed file. Obviously, we're going to get the same thing here because we closed the file, so we're going to get the same error here. It's just nice to know that with the context manager is what it's called when you use this with statement, that all of this is taken care of automatically for us. We don't have to worry about closing the file. Now there are some other cool libraries where you also have access to context managers. Not everything has it, unfortunately, but there are a lot of places where you'll probably use this or see or use this with statement again, and it just does a really nice job of like doing the setup for you, making sure things are open and initialized correctly, and then once you're done with it, just making sure things are like closed correctly, and you don't really have to worry about all of that. It just makes it all a lot easier. All right, so now that we're pretty familiar at least with the basics that we need to get started with the core of our application, before we jump into that, I want to quickly talk about setting up your local environment so that when you're developing, essentially your programs are always in the state that if you run it somewhere else, it will also work there. Because the last thing that you want to happen is it works on your machine, and then when you try to run it somewhere else, it for some reason doesn't work. So what we're going to look at now is we're going to look at how we can set up a virtual environment. And what we're going to do, and we'll see in a little bit what exactly that is, we're going to go into our Python. I'm going to do -m, type in venv, and venv. So this is going to execute the module here, venv, and it's going to create a folder that we'll see pop up here in a second called venv. So if we hit enter, essentially what this is doing is, for us, it's creating something called a virtual environment. And we can see here we have this folder created. If I actually go into it, then we can see we actually have a Python installation in here. Now to activate our virtual environment, we're going to go on macro Linux, we're going to go source, we're going to go into our venv folder here in the same directory, we're going to go into bin, and then we're going to go into activate here. And now we can see this venv actually showed up, which means that we're currently in our virtual environment. So if I look at, for example, which Python we're using now, and notice here I'm just typing Python rather than Python 3.9, although I could also use either I could either use 3.9 or 3 also. We can see here that this is the Python environment that we're currently using.
So on a Windows, what we're going to do instead to activate our virtual environment, we're going to type in benf, and then we're going to do a backslash, and then scripts, and again, and then we're going to do activate here, and there we go. Now we're inside of our virtual environment too. And if we want to deactivate it, we can do so just like this.
So we have our virtual environment activated. Now we also have the pip here. Now pip is extremely useful because it's our Python package manager, and essentially there are a lot of libraries that we can install that we can just easily do through pip. Now what libraries are, or modules, external modules, or anything, they come with a bunch of different names. I generally like to call them libraries though, is they are pieces of code written by essentially other people that are available to the whole, in this case, Python community. So there's open source code that is available to essentially everyone, and mainly people also just help maintain it, make sure it stays up to date, fix any issues that are within, and then you can also use it and include it in your projects. One of the libraries that we're going to be using is called Fast API, and this is going to allow us to very easily create APIs. So we're going to go ahead and type in pip install Fast API like this, and if we hit enter, it's just going to take care of the installation process for us like this. You're going to see it running down a little bit, but there we go. Now something else that we're going to need is something called Uvicorn, and we'll get into what exactly each of these things are a little bit later once we actually build out the API, but this is essentially what we need to run our application and make sure that it can actually receive all of the requests that it's receiving. So we're going to go ahead and hit enter here, and now with this we've installed Uvicorn and we've also installed Fast API, and we've done all of this inside of this virtual environment here. So I can show you, and we can actually just hit Python here in our console, and if I do something like import Fast API, then this is going to work. Now the import statement here, what this does is if we have this library available, we're going to import either certain components, or we can actually import all of it so that we can use it within our code. Because just because we have it installed doesn't mean that we're actually going to be using it. We have to import it first to make sure that we can actually use it. But again, you'll see this usage later on as we're going through the course, and you'll become pretty comfortable with it in no time, don't worry. To exit back out, we're going to do exit, open and close parentheses. That's going to take us out of this Python shell that we've created here. And to deactivate our environment, I'm just going to type in here deactivate. And there we go. We can see here the venv has disappeared. We are no longer in our virtual environment. Now to show you, if I go into Python 3.9, if I try to here import Fast API, I never installed it for this Python version, or for this environment of my Python, which is just kind of my global one. And we can see here it says the module is not found, can't import it. So in the copy of Python essentially that I have here, this virtual environment, I have Fast API installed and I can use it, but I don't have it installed in my global one. And so the reason that this is important is essentially for every project that you have, you want to have a fresh environment. This way, for one, you make sure that all of the packages that you need to run your code are all installed. And two, you also make sure that if you're using like a global environment, you don't have a bunch of unnecessary packages installed, because that's just going to take up a bunch of unnecessary space. All right, so we're going to activate our virtual environment again. And there we go. And now what we want to do is we want to have the packages that we have installed, we want to keep them in some sort of file, so that if someone else wants to run this program, all they have to do is create their own virtual environment, like we did with the Python 3.9 -m venv, install all the packages that they need, and they're good to go. So what we can do here is we're going to use a keyword for pip called pip freeze. And if we hit enter here, then we're going to see these are all of the libraries that are currently installed. And so what I'm going to do is I'm going to do pip freeze, and then we're going to use a Linux command, which is going to be this greater than simple, and we're going to have requirements.txt here. And essentially what this does is rather than having this output just to our console here, it's instead going to redirect this output from this command into this file. So you can see here it does not exist yet. If I hit enter, then we have this requirements.txt file, and we can see here everything that we have from this pip freeze has been exported here. And so this way, and you should do this every time you're installing new libraries to make sure your requirement stays up to date, because something that you don't want to do is like later on share this virtual environment. No, really only what you need to do is share this requirements.txt, and then everyone else can set up their own virtual environment, and they can go ahead and install all the requirements, and they should be good to go. So to show that, how we can go about that, we're going to deactivate our environment. I'm actually going to go in here and I'm going to delete our virtual environment so we can see it's removed. I'm going to just create a new one now, venv, so it's no longer here. I'm going to create a new one. I'm going to go in here and activate my virtual environment just to show you that I don't still have fast API installed. We're going to go into Python. I'm going to do import fast API. Doesn't work because we don't have it installed because we deleted our old virtual environment. I'm going to exit out. All right, so now we have this requirements.txt, and I want to just install all of it. So what I'm going to do is I'm going to do in my virtual environment, make sure it's activated. I'm going to do pip install -r, and then we're going to point to this file. Now the -r allows us to, rather than what we did previously where we just typed in the module name, essentially continuously import from a file. Since we have a list of libraries we want to install here, we can use this flag, point to the file that we want to, and install all of these libraries. So I'm going to hit enter, and we can see here it's now all being installed. And now if I go into Python again, and I do import fast API, bam, there it is, available for us. Very nice. So you can see this is really useful to just have reproducible environments. The only thing that you need to make sure of here when you're doing this is that when you're installing new libraries, you want to remember to do pip freeze and then into the requirements.txt again to keep this updated. Because what you don't want to do is install new stuff, keep your stuff running, and then forget to update this, and other people's, if they try to reproduce it or run it on their side, it's not going to work because they don't actually have all of the libraries listed here that they need to have to install. Something else that you'll also notice here is, although when we installed it, we did something like pip install and then like fast API, but really what we're having, or what is done here, is when we use this double equal sign, and over here we have the major, minor, and patch versions, so we have exactly the reference to what version of this module is used. So that way, if this gets updated later, it's still going to work for us. So this is really nice to just have in our requirements. It's kind of done automatically, but yeah, just in case when you see this, this is a specific indication to the exact version of what is being used. That way, again, when we use it later on and these things get updated, we're still going to be using the exact same version that we used when developing this. So even if new things come up and the syntax changes, it's not going to affect us because we're going to be using the specific version that we used when we installed. Obviously, you can change these things here to update to later versions, but when you're doing that, obviously you want to make sure that using the latest version, everything is still working as intended. Otherwise, there may be breaking changes in some of the updates, and all of a sudden things won't work as expected anymore. Now, virtual environments and the requirements.txt is one common way still to just manage your local environments, but there's actually a different way that is getting a lot of popularity called pipenv. So let's take a look at that now. We're going to do, we're going to go out of our virtual environment, just using our global Python system. We're going to, and I think I have to do pip 3.9 here. Let me double check that. Yep, so we're going to do pip 3.9. We're going to do install pipenv. So we're going to install this into our kind of global Python installation. And now we have this pipenv command available for us. So what we can do now is I'm going to do here pipenv install fast API. And we'll see in a second. We can see when looking into the logs here, after this is kind of finished, it installed fast API for us, it created a virtual environment for us, and it kind of took care of everything. And when we actually go into our folder here, it also created a pip file as well as a pip file.block. So if we take a look at the pip file, you can see here we have the packages installed. It also tells us the Python version, which is extremely useful. And there's also something called dev packages. Dev packages are nice because there are some packages that we want to use for development, for example, when we're writing tests, and they will show up in the dev packages, but we don't actually need them. We don't need to install them and kind of use up that memory when we're running the application, because all of this is just used for development. So currently we don't have anything for that installed here, but later on we will. And then we have the pip file lock, which essentially gives exact instructions of what exactly is installed, so that when someone else wants to set up their environment, all they have to do is, if they have the pip file and pip file lock, all they have to do is type in pipenv install, and it's just going to set up everything for them. But let's just go ahead and install another library, which is going to be the unicorn one that we also installed before. So we want to install this too. So if we do pipenv install and then the name of the library, then we're going to hit enter here, and it's going to add it to our pip file, which we'll see in a second, and it's also going to update our pip file.lock. And now if we ever want to install, so essentially we're downloading a library or downloading someone else's code and they have the pip file and the pip file lock, then if we want to install the whole thing, we're going to do pipenv install and without everything, and it's just going to install for us directly from the lock file, so that everything is going to be exactly the way it was on their machine. You can see here it also updated. I guess my machine took a little bit of time to have this file, the view, be updated, but once the installation is done, then obviously our files here are also going to be automatically updated for us, which is an advantage over using this requirements.txt, because that is something we have to remember to do manually. All right, so previously we had it that we would go into source, venv, bin activate, and we would be in our virtual environment and it would just constantly be on. However, currently we're still in our base environment. So there are different ways that we can go about this. One way is if we want to run something in our virtual environment, and you can also see the hints here, we can do pipenv run, and then for example, we could run main.py in the virtual environment. That way we don't enter it, but we're just going to be running this. Currently it's empty, so it's not going to do anything. We're just going to be running this one file in our virtual environment. Now, alternatively, which is also what I prefer, you can do pipenv shell, and then that's going to activate your virtual environment for you. And now we're within our virtual environment, and you can just do python main.py. Obviously nothing's going to happen. Print hello. Execute this, and we're going to print hello, and there we go. We're within our virtual environment, and this personally is something that I just prefer because it's a little bit easier to do all of this. Now to exit out of environment, our virtual environment, we're just going to type exit. That's going to exit out of our pipenv again, and scrolling up for the pipenv run, quickly correcting that syntax, do pipenv run, and now we can run commands within our virtual environment. So we still have to run, for example, Python main.py. And I'm pretty sure I forgot to put the Python up here, which is also, why it complained. So let's try that one more time. And there we go. So pipenv run, then we're essentially now running all these commands within our virtual environment. And we still need to run our Python, which is now going to be the Python within the virtual environment. And there we go. I mean, of course, personally, pipenv shell, we just go into it, and then we don't need to type in pipenv run in front every single time, but rather, we can just run things within our virtual environment, which just makes everything, again, a lot easier and a lot faster. And hopefully also you can appreciate and see that using pipenv is relatively easy, because essentially all that you need to do is just do the pip env install, and it will just take care of the whole installation process for you, keeping everything up to date, and you really don't have to worry about any of that stuff. Now let's quickly also see how we can install the dev package. I'm exiting, or have exited out of my virtual environment here. I'm just going to do pipenv install --dev. And we're going to install pytest, and we can see in a second, once this is run, it's going to just add it into our dev packages here, which means that when we install it, and when we run the dev installation, then we have all these development packages available. But when we are running the normal installation, so we can see here, opening it up, we have pytest installed here. Running the normal installation, we don't have it. So to run the dev installation, if you're running on a new machine, we're going to do pipenv install --dev. And that's going to set everything up with the dev dependencies. And if you then want to run it somewhere, you no longer need the dev dependencies to just install everything and get your environment set up. You're just going to do pipenv install, and that's going to install all the packages for you, but not the dev packages. So finally, sometimes what also comes up is you install something and you later realize you either don't want it, you don't need to use it, or like everything or something changes and you no longer need it. How can we uninstall it? So what we have to do is pipenv uninstall, uninstall, and then it's the same. So let's say we want to uninstall fast API. We're going to do pipenv uninstall fast API, and that's going to remove it from our packages here. And I'll skip over this loading again. And if we just, here we go, clicking into our file, there it's gone. And if we want to uninstall from the dev packages, we're going to do pipenv uninstall --dev pytest, and just letting this run and clicking into our file again here, having it reload. There we go. So that's uninstalled. And finally, also taking a look at our virtual environment that we did previously. So here again, we can see if we go into Python, we can import fast API, since this was the first step that we took. So if we want to uninstall this, we're going to just do again pip uninstall fast API, and that's going to remove it for us. We're going to hit yes here to confirm that we do want to install it. We go into Python. If we import fast API, it's no longer there, but we can see we're still within our virtual environment. So I'm going to deactivate that environment again, and actually what I'm going to do is I'm going to remove the requirements. I'm going to remove our virtual environment too, and we're just going to be using the pip file. So we can open up our terminal again down here, and in our pip file here, we're just going to pipenv install fast API again to make sure that we have that, let that finish installing, and this is what we're going to be using from now on, just to help us manage our environment so that everything, all of our libraries, all of our dependencies are properly kept track of for us. And when we share this, of course, we want to make sure that we have the pip file as well as the pipfile.lock. And if you ever need to update the lock, all that you need to do is pipenv lock, and that's going to update the lock for you. If you ever want to, if you're ever updating your pip file here to, specify a specific version or something like that, you want to update the lock, make sure all of that is consistent, then you can just type in pipenv lock, and it's going to update the lock file for you. But generally when we're installing, as we can see, the lock file is also automatically always updated for us, which just makes it nice because that way we can keep everything consistent. So in this lesson, we're now going to build our first application and just get it launched. There's not going to be much to see, but at least we will have something. So to start off with, I'm actually just going to uninstall all of this so that we can reinstall it to just make sure that we're all in the same place. Because we did the environment managing previously, so I just want to make sure that everyone is in the same place. So I'm just going to uninstall Fast API, and I'm also going to uninstall Uvicorn here. Now I'm going to reinstall it, so I'm going to do pipenv install, and let's go ahead and install Fast API here as well as Uvicorn, so we can see they're gone. And let's go ahead and open up this pip file again. So there we go. You also saw me use a shorthand here where rather than typing one after another, we can just separate the packages we want to install by spaces. All right, so what are each of these things? All right, so what are each of these things anyway? And yeah, that's what we're going to take a look at now, because we've kind of just installed it without necessarily knowing what it is. So we're going to start off with just using it. Each of these, like we talked about previously, are modules or libraries or frameworks that we were able to import and use in our application to just, basically it's going to take a lot of the work off of our hands, because they are open source pieces of code that really help us make the development process a lot faster. Because if we wanted to build some sort of server from scratch, it's going to be much more difficult because we have to take care of so many things, including like the network communication part. And with Fast API, it's going to be really easy because we're just going to say these are the places where we want the server to accept things, where we want the server to do certain things, and all of that will essentially just be taken care of for us, and we can just focus on writing the actual functionality, implementing the business logic, and we don't really have to worry about much of the technical behind the scenes beyond our implementation stuff. So if that sounds a little bit vague, then let's just go ahead and start implementing, and as we continue to use the libraries, I'm sure you'll start to appreciate and understand their exact purposes and really just see that they're to make our lives so much easier, because there are so many common things that you will need to do all the time, and they just kind of help us not reinvent the wheel, and they give us good implementations that essentially are optimized to do what their purpose is, and we don't have to figure out what's the best way to do it. So let's import, actually one second, we're going to go ahead and from here, we'll learn the syntaxes in a second, but we're going to say from Fast API, we're going to import Fast API like this. Now I just noticed actually my Python interpreter here, or PyCharm itself, has set itself up to use the wrong interpreter for this project. So I'm going to quickly show you how we can set this up so that we can actually get rid of these invalid imports because it's using the wrong Python. So I'm just going to go into our virtual environment, pipenv shell, and when we're in here, it's going to tell me the location of our virtual environment. So what I'm going to do is I'm going to go into preferences in the top left corner, which is currently off screen. We're going to go into PyCharm and then preferences. It's going to be the path on Mac. On Windows, I'm sure the path is pretty similar. Maybe it's like the file drop down, but anyway, we're going to go into preferences. Then we're going to go here into the project and then our project name, which is the same one as here. Python interpreter. We're going to click the drop down, show all. We're going to hit plus. Virtual environment. We're going to use an existing environment. 3 dots here. And now we're just going to follow this path down here. So we're going to go to dot local share
virtual environments. There we go, bin. And now we're going to use the Python here because we want to use the Python interpreter from this environment. So I'm going to hit OK and OK, and it should be automatically selected. OK, and I'm just going to hit apply and OK. And now we can edit configurations here, and yeah, so that should be there. And let's just check real quick if it's installed. Oh, it's weird, for some reason it is still not installed, so maybe something went wrong in the installation process. So I'm just going to quickly do pipenv. I'm just going to exit out of a virtual environment here, pipenv install, hit enter. That's going to install from our lock file, as we can see here. And let's just see, yeah, so everything should be updated. All right, let's go into our pipenv shell one more time, and Python fast, import fast API. There we go, so that works. So let's see. Everything is installed properly. And now it properly has our import here detected. It took a little while. You may want to just try hitting the green play button up here. That should kind of run it like this. Otherwise, you may want to close the file or reopen it, or you may even just want to restart PyCharm. I don't know why, but sometimes it hangs a little bit, just, trying to have all this stuff resolved, but it should be there. You should also be able to check it by, again, going into edit configurations. And, oh, no, sorry, that's the wrong one. Should we go into preferences again, into our Python interpreter here, and without touching anything, we should see fast API here, as well as uRecorn, which are the ones that are installed, and all these are kind of installed because we installed one of these two. And this should also be pointing to our correct Python virtual environment. So sometimes these squiggly lines take a little bit to update, but yeah, I'd recommend just trying this and just closing it and reopening it up again. If it still doesn't find it, closing the application, reopening it up again, and then it should be okay. And yeah, as a quick side note, generally what I've done always is typing in our, or in this case, we're in our virtual environment, so I can just type in like Python main, which will execute our main. But actually in PyCharm, it's a little bit easier because now we have a configuration set up here. I can just hit play, and that's essentially just going to run our main file here, because that is what we see here. That's kind of like the entry point, the file that is told to run from here. So you can also change like which file to run from here, but just as a quick side note, you can also do that. All right, so back to this. What is the syntax that we're using here? So what we're saying is, and actually let's simplify this first. To import a library, we use this import keyword. For example here, fast API, which means we're going to import this whole library. Now the thing is, for now, we really don't want to import everything because right now we don't need everything. And this is not necessarily a problem, but if you want to have just very lightweight and small resource usages, then it's generally better to not import everything, but import only the things that you need, because that way, you're using less memory. On the other hand, there's generally this thing that, people like to prefer importing everything, because that way when you're referencing stuff, you know exactly what module it's from, whereas when you're importing just subsections, you have to look a little bit to see what is from where. Obviously, there are like trade-offs, and it's still very common to just import subsections. You'll also even see it in like official documentations and stuff. And so that's also what we're going to do. So we're going to say from fast API, we're going to import fast API with an uppercase F as well as an uppercase API here. This syntax here lets us essentially import a subsection of the library. In this case, we're importing the class FastAPI. We haven't learned about classes yet. We will very soon, but first let's just get something running, get something on the screen, and then we can take a look at that. All right, so we have here from FastAPI, we're going to import FastAPI. And now what we want to do is we have access to this FastAPI class. So to create our application, all that we have to do is say app is equal to, and we're going to have our FastAPI here that we've imported, open and close parentheses. This is going to initialize the class. Again, you probably don't know what this means. That's totally fine. We will learn about this very soon. But now we have a version or a running instance of our FastAPI stored in this app keyword. So if we want to create our first endpoint, what we're going to do is we're going to write a function, and we can just call this home like this. And all that this is going to do is return hello world. Now on top of this, we're going to put a @ symbol here, and we're going to, and you don't know what this is, don't worry about it. These are called decorators. We will also learn about these later. Here, we do @app.get, and then we're going to have the path, which is just going to be a / for now, and that is it. And that's essentially it. Now we've coded a very, 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 very small application, and I'm going to show you just in a second how we can run that. I'm going to open a new window and just make this a little smaller here so that we can see that in a second. And to get this running, we're going to go to Uvicorn, and we're going to say main : app. So what this means is we're going to use Uvicorn to launch our application. And our application is found in the main file. This is called main.py, and the class that we want to launch is called app. So that's the syntax that we're using here. Hit enter, and now you'll see it says here Uvicorn running on, and we have this address. So you can either click on this directly, or I'm going to just type this into my address bar, and let me actually show you so we can see here. One thing you'll notice is this is the address here says 127.0.0.1, and then it has a colon here, 8000. So this is the port that we're running on. This here is the address. This address here is the same as our local host. So you can see I can use this. I can also do 127.0.0.1. Hit enter here. It's going to do the same thing. It's just going to return hello world, as we can see here. Now there's actually something really cool that we get with FastAPI for free that we're probably not going to appreciate right now, but later on we'll see just how nice this is. If we go to /docs, we're actually going to have documentation, OpenAPI documentation generated for us. Again, this probably means absolutely nothing to you right now. Totally fine. We'll see as we go through the course. You'll see what this actually does, why it's useful, and yeah. So just as a side note, we have that available to us here, and we can see here our application is running, and also when things go wrong, we will also see the errors here. I'm going to shut this down again. Generally, when we're developing, it can be pretty useful to have here -- and we're going to do reload. Now, what this does is, if we just go back to our main page, when I change some code, and actually, just as a side note, I'm going to put an extra empty space here because it's nice, it's good formatting to have our function definitions here with essentially 2 spaces between our previous definitions of variables. So instead of saying hello world, I'm going to put in here new hello world. And as soon as I save this, you can see it's shutting down the application, and then it's starting it up again. And now when I refresh, there we go. We can see it updated. So using this -- reload, is going to be pretty helpful because we don't need to relaunch our application every single time, but rather as we're developing and as we're saving our files, it's just automatically going to relaunch the application for us, which can again just save us that little bit of time. So with this now, we've started and launched our first application. Obviously, it has almost no functionality, but it works. And the cool thing about this is, look at how little code we had to write. Essentially, we were able to make use of two very useful libraries. One of them is Fast API, which kind of takes care of the whole setup for us. And the other one is Unicorn, which sets up this gateway so that when we actually visit the web address and we type in something, all of that information is properly passed on to our application. And so with these two together, we're able to do this. There's one extra note about Unicorn, which again won't mean much to you right now, but something that we can actually do with Fast API is we can also write asynchronous methods, and Unicorn provides support for that we can have this asynchronous application. Again, probably won't mean very much to you right now. Don't worry about it. We'll go through everything, and yeah. But yeah, so congratulations, we have our first application running. We're able to make use of the libraries for this, and we'll see as time goes on how we can extend our application, how we can add more functionality to it. And if you also don't know what an API is, then essentially what we're building here is some sort of backend server that has different web addresses, or different endpoints rather, available. So you can see here we have the kind of standard slash. So that happens when we go to either the empty one, but also just here. This is what we get here. But we can add a lot of different routes that we can go to that will provide a lot of different functionality. And so this is essentially what we're going to be using when you're developing and you want to make services available to, or you just want to build services. Then services can interact with each other and talk with each other by hitting these different endpoints, and also front-end applications, which we're not going to be focusing on, can actually go to your server and look at specific endpoints, get information from it, and use that information that they get returned to properly format and display it all in the front end. But again, this will probably make more sense as we just continue building the application, and you'll get a better understanding of what we're setting up, how it's working, and how it can be used. And finally, to quit our application, I again just hit Control C, which is going to just stop that like that.